Devops, something that he'd kind of cooked up.
Okay, I guess if I'm up, is that right?
You're up.
Okay, I don't have much really to go over other than the fact that I think I had an epiphany and understood what people started talking about when they said DevOps, because I don't seem to know the difference. I've been around a long time, and I got out of school, it says a long time ago. Uh, but what used to happen, because I used to draw whatever program or thing I was drawing, I would write it down and end up getting key punched. I'd get a deck of cards, carry a deck of cards. They'd load it into a 1401 system, Model 20. Then we worked our way through. And, basically, I've been always not thinking about what part was development, what part was operations. So I signed up to go to a CNUG group. It was downtown in Marriott, and they had two rooms set up, one for ops and one for dev. So I go into the dev room and I said, all they're talking about is the the supervisor, the hypervisor, and the other thing, how they're all tied together. And I said, I'd really like to know, how do I get the pieces into that separate from what it was? So I walked out of that one and went into the ops meeting, which was two different rooms. And that operation was pretty much doing all the things that went into the program, and it was really covering the people who did the kind of the jobs to make it work in the other room. But boy, it seems to me that it's really weaved together, and there's tendrils of both of them going into the other one. So it's difficult to say whether you're ops or you're dev. And so I titled this one, I think, when we started, it says either going to be DevOps, or it could be Ops Dev. I don't know how you look at it. But basically, what's happened to me is I'm up to 80 now. It's been a long time doing different things. And what I generally do is follow the instructions. Uh, I go to the grocery store and they got a special place for me to barbecue. And I think that's pretty nice. Other than that, uh, I got back into this ONUG meeting that was a couple weeks ago. And that was almost all operations done by people who would come in and handle the input part of the company and the things to put it together for the company. And that's kind of when I came up with the idea that I guess the ops are the people who present the stuff going on so that it ends up being published in the way that you want it to be published. And of course, at that time, I noticed that one of the things that I had been running for years all of a sudden didn't update. So I went back to take a look at it. And my problem was, and I'm going to click this one down here. And I don't know whether you can read this. This is one little part that I had running, and it runs on a cron tab, and it runs, I think, 4 times a day. And the whole purpose of it is to update uh, a light list of instructions for operators that are doing Coast Guard work in the area around St. Louis, as far up as Peoria and out to the Gasconade River and on down to Chester, Illinois, that kind of an area. And I was in charge of that in a side job that I had with the Coast Guard Auxiliary, supporting the Coast Guard. But one of the things they do is they publish a list of everything that is being done on the rivers. And then they have to change that list because certain lights are not working. Something's off. Some things are important, some things are not so important. But one thing that happened in Arkansas, I'm going to say probably 20 years ago, 25 or 20 years ago or so, is a barge hit a bridge and knocked the bridge down, and 14 people were killed. And of course, the barge guys say that the light wasn't working on the bridge, and the bridge people say it is working on the bridge. But the problem was is that it had been reported for 4 years that the light was out. So now the responsibility went back to the owner of the bridge, which is a highway bridge. Obviously, the government owns it, and they went back and assigned a lot of blame to the Coast Guard for not making it happen. But the Coast Guard only reports it and lists it, and whoever's supposed to handle that is supposed to take care of it. So I wrote a little script here, and this script isn't very big. It's only got, I don't know, it's about 5 active lines, and they're really not 5. Some of them are compound lines, but they were written back in when I was active in that, which was 2007 up through maybe 2017 with the computer. I had 20 years of action there on our AOR for that area I was talking about. But what this was trying to do is adjust the the light list that we carried in our local boats here to only have about 19 pages of information rather than the 200 pages that are issued that you have to hand update each week. And what happened to me, if you look down, I don't know if you can see my cursor on this, but the first thing here at the start is that I'm only interested in certain light list pages, the pages for, and they're listed here, 50 to 53, 57 to 58, 99 to 107, 127 to 129. And I set up a web page, and I just set it up on my current machine in my own user's place, and you find it here. And there is some print matter that is on the front of the light list that tells people what everything really means, but it's static and it's always there. So I call that the front matter, and that I don't need to print that for people on the boat. They print it once a year themselves, and it's available with the HTTP Nav Center, U.S. Coast Guard government. So I don't need to handle that. But I did want to have something that we called a updated light list that would have everything in it for us. So I listed it out here, and it starts out basically, I have to take the information from the Nav Center for the Coast Guard, and it's a PDF thing that's issued every week, and it is weekly updated with changes that are necessary. So all I have to do is print the pages out of that are updated, instead of having to make sure that each of the boats on the river has the information there. They're all supposed to be masters, and they're not supposed to sail in waters that are that you don't have an accurate list of what the navigation marks mean. And underneath this top little section, I put, but I'm only interested in our Illinois River, the Kaskaskia River, the Upper Mississippi River, and the Missouri River. Those are the only ones that I'm really interested in. Those are the only ones in our AOR, our area of responsibility. And so I said, what I should do is just set up a little program. So here's a little program. Maybe this is called development. I don't know, but I want to change to what I'm going to call the full web page. And I'm going to change to that directory in my home computer. And then I'm going to do a wget against the Coast Guard list, and they have that updated light list that they published up there. And that updated light list V, might say, that's a complete light list. And I look at that and say, which is newer, the one that I'm calling that, or the one that they have now? And so I go in there and I only check it once, the web page against it, the weekly changes. I want the newest one, either the one I have or the one they have. Well, what happens is as the day moves, I keep updating mine. So once I've done it, I never see it again until this particular statement actually executes. And if it does, I have an end statement here, and then I carry on to the rest of it. And what I do is I just start at the front and run the ASCII to PS little routine on the PDF file, and I check it that I'm looking for the front of that page to have it titled, and the title is going to have to go through the notice to mariner, which is going to be a number every week that ends in /22. So it starts with light list, ends in 22. So that's a very simple thing. And then I tell it to pull that out of there and send a little note to me to put on my desktop to tell me that you don't have to worry this time, Dave. And that's the end of the program. And that's all that's been running for a number of years. And every year I'm supposed to change this number here, this 21, that's the last 2 digits of the year that this program's running. And I had forgotten that the first part of this year, because the way that I check it is I do a properties list of that file, and it tells me what its update time was, and that's all I needed to know. So I didn't worry about it printing out here. So I fixed that. And then as I was sitting there fixing it, I said, I didn't really affect the program at all. I just affected how it got printed out. And I said, I guess I'm really ops. I'm the guy that's feeding the data to the program that's actually working. I did have a section at the bottom of this that said that I have to check that one of those files doesn't disappear on me and I automatically update something that isn't there. But that would happen if there was some kind of a failure on downloading the full list. And that size, it's going to be greater than 10,000 characters or 100,000 characters. So I said, I'm not going to worry about it. And so I just commented that whole thing out about when I retired from this activity, which was, I think, 2013, 2014 area, I got out of it. But I just thought that it kind of explained to me the difference between the development side and the operation side. Still has it kind of variable things. Sometimes you have a little piece of this, sometimes you do everything in the other side. But the other night, we had a discussion at one of our local meetings, and people talked about, how do you know which side you are? Well, you're really not one side totally anytime you work, I guess. But when you're running in a company that they change web pages every week for ads or information, this is an information one that is important to a lot of people who are operating on the river. Anyway, I thought I'd turn it over and see, does somebody else have an idea of what is the difference between ops and dev? I'll pass it on to you guys. Not hearing many comments.
One thing I've heard is it's who gets the call at 2 a.m. Whoever that is ops.
That's a good way of putting it. One's responsible for making sure it runs. The other one makes sure it does the right.
we had a system that was dump crashing and taking a core dump around 2 a.m. randomly in different days. The customer didn't seem to know about it, didn't seem to be worried that his program was crashing. The only problem was after a couple of these dumps, it would fill up the partitioning and the whole system would come down. I was being the guy that got the phone call at 2 in the morning. I wrote a script that ran periodically and look for a dump, compressed it, stored it somewhere else, and cleared out the area. Didn't want to get any more phone calls. It was like Devops.
I say that's like my entire life. I literally had an application that, a Java application that would just eat through memory like no beginning. I installed a utility called GlowRoot into the context, so it gets started up with the Java application, and it had a button on it that says "Do garbage collection." I may have programmed a little Python script to go in there and poke that button every 15 minutes. Never got, unless they were doing something stupid, I never got it never crashed again.
So it crashed every day, right?
It would
After you
crash
made that
whenever they
change?
would shut, they would go through like 2/3 of the day trying to push a whole bunch of material through the application. And then it would just, I gave it 16 gigabytes of memory and it would still eat through all that memory.
Sounds like a memory leak to me.
Sounded like memory leak to me too.
Mhm.
I think we did 1 or 2 things and it's been behaving now, but I've just left the robot sitting there and poking the button.
But if there's a button for garbage collection that can fix it, that's a memory leak is something where you don't get it back. It's got to reboot.
Well,
If you got a button to fix it, it's not a memory leak, I don't think.
Well,
it was a memory leak that wasn't being caught by the garbage collector, or wasn't being garbage collected properly by me using the GlowRoot button to trigger a manual garbage collection within Java. It would fix the problem.
You think, Tyler, that is what? The operations part of the problem, or is that a developer's problem?
Well, since it's the operations of it's a Band-Aid solution to solving the
Aren't they all?
functionality. It's a dev problem or an ops problem. It's me covering for the dev person not doing their bloody job right and coding the damn thing right.
That implies half the code base isn't already bandage solutions.
Trust me, you want a textbook case of sunk cost programming. CA Identity Manager is it. They have an LDAP server plugged in that has that's designed for provisioning accounts, that's plugged into a Java front end, which is plugged into another Java front end that actually has a nice interface. These guys throw no code away.
sounds like Microsoft.
If it worked last year, it'll work this year, right? Right?
Tell that to my blood pressure.
Yeah. Hey, I just had an idea for a little short talk some month. How do you use LDAP?
You really want me to go through that? Because I could do that like in my sleep.
I'm sure you could, but why don't we set something like that up?
I think Sean T put in the chat, there are little blurry lines like this all over the industry, like ops and security. If I set some permissions to 0644 instead of 0777, am I a security person now?
Yeah, that's a good question.
Yeah, I do believe you have just pwned the system. You're a penetration tester now.
It's the same way with DBAs, right? Every database runs on a server, right? But then
Yeah.
it's somewhere on that system we draw the line like, oh no, that's the ops, that's the SA has to do that. That's the server part. Or oh no, the DBA has to do that part. That's the database part, you know? But it's like, where does this line get drawn at? It's very fuzzy to me.
You know, it's a bad sign when you call the DBA up in the middle of the night and they go, "Did you check the server space?"
Oh, it's like with me. I got woke up this morning because the backups were running, so the logs on the SQL server piled up and were never cleaned off.
Ooh. Log
I've been
rotate?
fighting
What
with
is
this.
that? Yeah.
And the stupid thing is this is MS SQL. I have never had this problem with Postgres. Postgres just sits there and runs. Windows, Linux, Mac, it doesn't give no damn. It is literally the honey badger of databases. I throw
I think
gobs of garbage at my Postgres database and it goes, okay.
Can you find it back when you want it?
The data?
Yeah,
Yeah, usually.
okay.
It's within specifications.
Piece, which is the soul, and we're going to put a
don't think I heard that.
I think what the term DevOps means is there's a lot of people that are in the business of making sure that the business is running. That's how to write their own code to make sure it works on the fly. You don't have a traditional development cycle test, all that stuff, and then you get to walk away from it. It's okay, how do we fix this now?
Yeah, that's probably what it means to a lot of the people. I think the original idea was the development teams and operation teams would actually get together and talk about, yeah, here's the resources this will need while developing, and scale it up and scale it down. And if you're really fancy, dev people will write scripts and Terraform and all sorts of stuff to automatically scale, depending on the needs that day.
Yeah, I think this is a good topic. And what I've noticed is that, you know, I'm doing more and more dev stuff all the time, writing code now, and I'm doing all the stuff, but for jobs, they want you to have a certain number of years of experience in X or Y or Z, you know? And so it's just, you know, even though I'm doing everything, I don't have necessarily years of, I'm not comfortable saying I have years of development experience, even though I have been doing a little bit of this and that for quite a while. But, you know, they want you to do everything, but to get the job, you have to already have done everything for X or Y years, you know?
Yeah, just say you've done it. It's better than a lot of people in the industry.
Oh, it's like right now I'm working on a security issue where I need to go through and take the users in this one system that I have backend access to its user table, compare it against HR, compare it against the global list, and make sure and weed out the people that my team have forgotten to turn the account off on.
Gotta remember you talking about that years ago.
It's literally, if I was to describe my job, is I'm a data engineer. I take data from 9, 10 different systems and I shove it all together and try to figure out where's the security hole.
Yeah.
Where did we screw up? Where did we miss something? And then
Doesn't
automate.
It's
Doesn't,
everywhere.
change with the way things go on, and we get different people to get involved, and all of a sudden they change something that you've got a hole that showed up that wasn't there when you first started, or maybe a kind of a bleep in some of your suppliers' programs that are sitting there you were responsible for, but for some reason they changed that in the middle of an update, and it was collateral. It was all collateral to what you're trying to do, but it turns out to be very important. That's the thing that really makes a difference to me. You're really responsible for the job.
Your job is to make sure that the business people are happy, and then sometimes it really can go sideways, especially when they have no idea what they want.
I seem to remember that's most of the time.
In reference to Dave's initial question, it seems to me the whole concept of DevOps seemed to kind of be developed to address exactly what you were saying here. Management just doesn't like when, okay, did the operations people screw up scheduling this, or when the program doesn't, when the logs fill up, is it a developer's fault for not realizing it, or the operation, and management just doesn't want to have to figure out, is it an operations or development? So we'll call it DevOps, and we'll
Mash them all
somebody.
together.
Yeah. Somebody will pay for this.
Yes, that's the problem. You don't want to be blamed for everything.
Well, that's the situation I work in right now. I do government contracting, and we're contracted only for development, and we have to walk a disk over to the contract that's only for testing, and then once they are done doing their testing, they walk that disk over to a different contract that's only for running the production environment. And since it's 3 separate contracts, we're all trying to look good to the customer. So we all spend a lot of time pointing fingers at each other like, no, this is the tester's fault. Their environment's all messed up. No, this is ops fault. This is the developer's fault. It's the exact opposite of what I think the industry is trying to go to with this DevOps stuff.
One of these days, they're going to take Git and apply it to the government, and then all the stupid bureaucracy is going to be out there for public
Consumption
Peruse.
and rage.
You mean it's not out there now?
Oh, there's a project right now to apply to put the Federal Register into Git and mark up all who changes what.
What?
So if your little friend over in New Jersey decided to throw his little pork project into Bill such and such, but it changed the register, the law 2/3 of the way through the register away from what they were talking about, it's going to put his nice little, you can run the blame tool and point to him.
But what if one of those representatives runs Git blame someone else?
I think that's because, or that's, I don't know if they have the access to exactly who wrote what.
Yeah, but it'll show change at this law on this time, who voted for it, who voted against, probably.
Oh, that's all in the merge request.
I fully support this idea.
But I mean, it's funny when you go in and you say, okay, this is how Git works. It's used for code. No, it's used for anything that's text.
Yeah.
It's amazing what happens when you say, show me everything that this person contributed to. Huh. Well, the problem I have is there's only one person contributing to my code at work, so there's no point in running the blame tool. It's always my fault.
Yeah, but sometimes you're hoping to be surprised.
I'll give you an even more expansive problem, not just DevOps, but the traditional problem is when you bring in a contractor, and I'm doing some stuff with a group that yeah, they let a huge contract out. It wound up being subcontracted to a group in India, and fine, they're developing, for the new software. The thing is, they're doing things like, okay, well, we're going to change the way the accounts are different on this, and the customer is like, that's not when our fiscal year changes. It's like you can't just in the middle of the fiscal year or with 3 months left in the fiscal year just arbitrarily say, okay, maybe this department is going to be on the new system and that department. I mean, it's one more level of screwing up the ops end of DevOps. So.
Oh, don't get me started about my bloody HR department.
What'd you call it?
It's been my bloody it's been so bad that they changed their name from HR to Peoples and Organizations. We literally have cursed HR for the last year as they roll out Workday because they literally listened to everybody and did nothing that we told them to until the very last minute, and then they ask, "Why is everything broken?" I had to say back to them, because people, more than your code had to be tested.
Okay, well, to travel on, is there any other comments, questions, specifically on Dave's presentation here, or should we go to general announcements, general Q&A, and then off to our main talk this evening?
Well, I don't have anything further to say on it, so I think we got to move on.
Okay. All right, we'll move on. For those of you who haven't been with us for a while, or maybe it's your first time, we do the Oreo cookie version of meetings. And what we do is we have a presentation on the front, which is what Dave just did. And then we do the announcements and general Q&A here in the middle of the meeting. And then we go to our main presentation for the evening. So first off, since we don't do introductions on the very front, kind of post introductions. That was Dave Forrest, who did our DevOps or Opsdev presentation earlier. Thank you very much, Dave. It was a very interesting insight into where the problems can arise. And we appreciate you putting it together. Dave's a longtime member of our group, an occasional presenter, and been in the industry for, as he points out, a long time. So let's see. So later this evening, as soon as we clear these announcements and general Q&A, we'll have a main presentation by Scott Granneman on hardware. And now, as far as announcements, let's see. Let's see. Lee, Stan, you got anything that needs to be announced?
Can't think of anything, Gary.
Okay.
Do we have any schedule changes for next month we need to announce in advance, like our holidays or Thanksgiving?
That would have been a good thing to check, and I did not check. Stan, I think you were looking at the calendar. Any catch anything different?
I'm still planning. This is Stan. I'm still planning to do the newcomer group on the 4th Tuesday of the month. In December, Christmas falls on a Saturday, so we can either do it the week before or the week after. The week after is the normal 4th Tuesday. So, and I've already asked the participants at the newcomer lug in the last 2 meetings and got no preference. So I will probably just remain with the normal 4th Tuesday of the month for the newcomer lug.
Okay.
If somebody gets really desperate for something, we could fire up a meeting maybe in the week before Christmas. But I figure that people are probably going to be doing shopping and things like that, and they can only take so much of this stuff, regardless of how wonderful we are.
Yeah, Christmas, the holidays are always an awkward time to people have time, but then they want to be spending the time on other things like family, holidays, etc. So, all right. So yeah, nothing of that nature. I do have a minor announcement. There's tomorrow at 11 o'clock. If you look at the SLUUG calendar, there's a Linux Foundation webinar that's available to go to. The title is Rust Language for Linux, Safe Abstraction Drivers. It's from 11 a.m. to 12:30 p.m. And as I say, it's for those who would develop in Linux. It looks like it says there's no prerequisites. You don't have to have any background in Rust, and it looks like it will largely cover, why would somebody want to look at Rust? Why, what's going on? Why is it a new language they're integrating into the Linux kernel? So if you're wondering about that, or just what Rust will do, how it's different, go to this talk tomorrow.
That's the Linux Foundation
Yep.
thing?
Yes, it is. There's more if you want to scroll down there a little bit, Stan. There's the whole abstract.
Free?
Seems to be free.
Okay. Okay, and it's on our calendar. Thanks for putting it on the calendar, Gary.
You're welcome, which is another good point. Thanks to Jonathan Drews. And if I'm forgetting anyone else, Jonathan sent us a number of opportunities for different meetings out of town, which of course now in the age of Zoom meetings and Jitsi meetings, we can go to these all over the place. So so Jonathan's been keeping an eye out for BSD oriented meetings, and he's found some interesting ones. I think next Tuesday night at 7 o'clock, there's a free BSD meeting.
Yeah, Gary, if I could just interrupt.
Sure.
It's Jonathan here. Deb Goodkin of the FreeBSD Foundation, who is herself a coder. She worked for Maxter Corporation and IBM as a firmware coder. And she has a master's in electrical engineering. She will give a presentation on resources for FreeBSD. So you want to know how to be a contributor, a porter, make ports. She'll go over that, and the FreeBSD handbook and things like that. So it's not simply badgering people for money. It's actually technical stuff. And that's next Tuesday, November 16th. I'll post the Jitsi link the night before. Monday night, I'll post it to SLUUG. Is that okay if I do that?
Yes, definitely. Definitely.
And then, Gary, in January, Al, can I just say this quick announcement? What's his name? Alan. I can't remember his last name. He's a FreeBSD developer. He'll give a presentation on the ZFS file system and how it was developed. So that's in January.
Nice.
That may be of interest to you.
Nice. Speaking of ZFS, the ZFS Developers Summit was Monday and Tuesday of this week. So it just finished yesterday. And it is on our calendar. So I think there's a URL there, and I haven't checked to see if any of that was left online, if there are videos or written documents, but let's make post and check it on that. Also, Jonathan, I think it was you who brought some other things to the calendar. There's Semi-Bug, Southeast Michigan. And I think
that's the one that I'm doing the presentations through. I'll try and get some speakers for SLUUG. I had email troubles. I'll resubscribe to SteerCom, and maybe in 2022 Deb can come here and give a presentation. She's given presentations at Linux groups. Right.
Nice.
So she's more than happy to do it.
Okay. One
Yeah,
last thing off the calendar, there's a group in Chicago involved in quantum computing. And so for the last couple of weeks, I've put them on. They frequently meet on Wednesday nights. They also frequently meet on Sunday evenings. And so if you have any interest in quantum computing, they've brought in some people who are working for companies who are building the machines. And then other times they get out an academic textbook and talk about, this is why this works in quantum computing and those kind of things. So yeah, look at the calendar, and I think there's one coming this Sunday night. So.
Can I say one last thing?
Yeah,
Quick, Eric.
Mm-hmm.
This is for Ed Howland. Ed, I'm about halfway done converting your SLUUG presentation on Markdown to LibreOffice. So I hope to get it sent off to you, and then you can proofread it. I'll send a PDF. Okay, Ed? Is he still here?
Can you hear me?
Yeah, I can hear you.
Yeah, that's fine, and I'll put it up on the GitHub page when you're finished, and then hopefully, I don't know if the SLUUG calendar, not the SLUUG calendar, but the SLUUG presentations page, is there a separate link for the slides? In addition to the MP4 file, is there always another link for the slides? I'm asking.
There can be.
Okay, so
If someone-
there isn't currently one for the Markdown that I gave a year ago this month. So when Jonathan has kindly offered to convert my Markdown slides into a PDF file, and once that's done, it would be nice if we could just point the URL directly there off of the presentations page for that link, and the easier to read for some people, I guess. So
we can do that, Ed.
Okay. Thank you, Jonathan, and thank you, Stan.
I'm going to send the files to Ed, and he's going to then forward them to you. Okay, Stan?
That works for me.
Okay.
I've been allowing things to run a little long than what I thought, and I know there's some people who are here mostly for the presentation. Are there any really pressing general Q&A questions that we need to do now before we get into the main talk this evening? There'll also be some time after the main talk to do general Q&A as well.
I don't know why, but
Somebody has an open microphone, I think. Okay.
Yeah.
If no one absolutely needs to do a general Q&A, I'm going to introduce our main speaker for the evening. And so last chance until after the main talk. So our main speaker this evening is Scott Granneman. Scott's a longtime member of our group. He's a principal at the company called Web Sanity, and he also is an adjunct professor at Washington University and Webster University. Occasionally some other adjunct roles, and so it's always an entertaining evening when we get Scott to speak, because he always takes us somewhere that we didn't expect, and always an intriguing talk. So we always appreciate it. And with that, I'm going to turn it over to Scott.
All right. Thank you very much. So those of you that have known me for a while might be thinking, Scott looks a little different. And that's because recently, without intending to, I joined the Hair Loss Club for Men. And so I decided just to go all the way and take it off. So that's what's going on. Or I could be joining a cult, one of the two, maybe both. Yeah. So I'm going to go ahead and share my screen for you guys here. And hopefully you are now seeing my, does everybody see slides? Is it finally fast enough?
Yes.
Okay.
Yes, Scott, we're
Excellent.
seeing that.
Okay, cool. So this is actually a bunch of different stuff. When I talked to Gary a month ago or so, I was tossing out ideas to him, and Gary was like, let's do all of them. So that's what's going on here. So this is a bit of a mishmash, but I think it all works together. It does all have to do with kind of new, sometimes cutting edge computing. I'm focusing a lot, as you'll see here. I'm looking at the new Apple CPUs that were announced just a few weeks ago. I'm looking at the new Intel Core, 12th generation Core that came out just in the last week or so. I'm looking at Google Tensor, which is Google's first chip that they're including. And I'm looking at the Framework, which is a very interesting new modular laptop. And so we're going to be covering all these different things. And in some ways, many of them relate to each other. So I think you'll find it kind of an interesting mix that actually works pretty well together. So before I start talking about the M1, I wanted to talk first about Apple's CPU history. And this is just a couple of slides to kind of make sure everybody's on the same page here. And Apple has had a very interesting history when it comes to the CPUs that it's used over the years. And I hope
Scott, we're seeing just a blank white line vertically down the middle of the black page.
All right, let me fix that. I know what's causing it, I think. Where did Zoom go? Where did Zoom go? This is weird. Why can't I find the sharing screen again? Okay, how about now? Is it back now?
Okay, yeah. Looks like there's a timeline here.
Yep.
Yeah, okay. I moved it to a different window. Apparently Zoom didn't like that. Okay, so this is a timeline.
One other quick question. Will the slide deck be available for us to download
Oh,
later?
hell yeah, they'll be available. Absolutely.
Fantastic.
Oh yeah, of course. So this is a timeline I made. I hope you enjoy this because this took me a while. I'm happy with how it turned out though. So back in 1984, when the first Macintosh came out, I used it. I'm sure some of the other old timers on here used it as well. That used the Motorola 68000 chip, and it was pretty low powered in the day, but it served to get the Macintosh off the ground. And then in 1994, Apple made a big switch because the Motorola 68K series was pretty much not working any longer at all. It wasn't keeping up. It was slow. And so in 94, they switched over to the PowerPC chip, which was a joint alliance between Apple, IBM, and Motorola to create a new chip. And Apple used that for quite a while. During that time, though, Apple made a venture into a non-computing product, the iPod. And for that, they couldn't really use the PowerPC and they couldn't really use an Intel chip. They simply weren't appropriate for that device. So instead, they turned to ARM. And of course, those of you who know anything about, I'm sure you've heard about ARM in the past, certainly 15 years. But that is a chip company that was always focused on mobility, low power usage, kind of a good balance between power and capability and speed. And so the ARM was a lightweight, but speedy enough, but mobile chip that Apple found was perfect for the iPod. And so that's the first time Apple really started getting involved with ARM. And in fact, Apple invested a bunch of money into ARM around that time as well. Well, in 2003, they were still using the PowerPC, but they switched to 64-bit. They were one of the first personal computer companies to switch to a 64-bit chip in 2003. But then the same problem that had happened with the Motorola 68K series was happening to them with the PowerPC. It wasn't able to keep up. Intel was just thrashing them at that point. And so in 2005, Apple made an announcement with the CEO of Intel on stage that we're going to be switching to Intel processors away from PowerPC. So this was now the second time they'd made a switch from one architecture to another. And they have remained on that until 2020. Now, in between, in 2007, they released the iPhone, which has proven to be, as many people have said, probably the most successful product ever sold because of the billions and billions of dollars Apple has made and the number of people using it. And for that, they turned to ARM again, and they've used ARM. Well, a few years later, Apple bought a small company called PA Semi, and it was a small semiconductor company. And at the time, people thought that was really weird. Why is Apple buying a company with chip expertise? And it didn't make a lot of sense to people. A few people thought, well, maybe they're going to make their own chips, but why would Apple do that? That's really weird. But then what happened is that within a few years, Apple released, starting with the, I believe the A4, Apple started putting its own chips with its own designs, all based on ARM, inside the iPhone and the iPad. And they really developed an intense expertise when it came to integrating ARM-based chips into their products, so much so that, and this had been rumored for years, but in 2020, they finally released their own desktop CPU, the M1, which I'm going to talk a little bit about. And Apple announced that this was only the start. They were transitioning entirely to their own chips away from Intel. So this now makes the third time that Apple has changed the underlying architecture of its devices. And this has been probably the most successful of all in terms of the product itself as the chip. And as any of you who know Apple know, they like to control the whole stack. Ideally, Apple wants to be in charge of the hardware and the software, but increasingly every single possible aspect of the hardware as well. I know some of you think that's bad, some of you think it's good, but be that as it may, that's where they are. That's the company's vision, and that's where they've always kind of played. And then just a few weeks ago, they announced the M1 Pro and the M1 Max, which I definitely want to spend time talking about with you guys. So they've done 3 architecture shifts since 1984, PowerPC, and then Intel, and then ARM. And in terms of their desktops, ARM kind of started earlier with the mobile devices. However, interestingly enough, and I didn't really get a chance to put this in here, but they've actually switched the iPad Pro over to the M1 as well. So at this point, the iPad, which was already the fastest tablet you could get, is now so ridiculously faster than its competitors that it's ridiculous. There you go. I'll reuse the term again. So that's the dates when they did this. The thing I want you to notice is that in November of last year, just a year ago, Apple released the M1, announced the M1, released the M1 inside the MacBook Air, the 13-inch MacBook Pro, which is the smallest, and the Mac Mini. Now, what's notable about that is those are the lowest of the Apple lineup when it comes to Macs. Those are the lowest powered. They're certainly some of the biggest selling. The MacBook Air is really, really a popular computer. I generally advise people that are interested in a Mac, unless they have very specific needs, to just get a MacBook Air. But they released that in the low-powered machines first. And then in April, they announced that the M1 was now going inside the desktop. So the iMac, and as I mentioned, the iPad Pro. And then finally on October 18th, just a month ago, they announced that the M1 Pro and the M1 Max, which are the successors to the M1, for Pro machines. And these went inside the MacBook Pro 14-inch and 16-inch, which are all also new form factors for them. And so, and these devices have gotten just amazing reviews. So that they've been pretty successful with this transition so far. So we're definitely going to look at the M1 Pro and the M1 Max because their performance is extraordinary, as you're going to see. So let's talk about the M1 for a sec. So when Apple announced the M1 in 2020, June of 2020, they said, we are going to be transitioning all of our computers over, and it's going to take about 2 years to complete. So you'll notice we're a little over a year into it. And basically what's left is the Mac Pro, which is, and the bigger iMacs. So the big iMacs and the Mac Pro, which are the big, beefy, professional desktop models, have yet to have made the transition over. I'm going to talk about that when we get to that a little bit down the road. So what's happened is, and this is one of the most interesting things about this, is if you look at the traditional way laptops are built, and I actually have a slide showing this here. Traditionally, you have a CPU, you've got the memory, you've got the GPU, you've got the other chips on the main board, and they're basically separate chips. And so, and granted, things have gotten very speedy, but it still introduces a lag time. It still introduces a wait as the devices, these chips, have to communicate with each other. And so what Apple decided would make more sense, and certainly their background in making chips for phones and mobile devices where you have to do this, played a factor in this, but they've moved toward a system on a chip, an SoC. Well, in the case of smartphones, you absolutely had to do that because space is at a premium, and you needed to reduce the power consumption of these devices and giving more time to the battery. And a system on a chip made a lot more sense for that because now it's all in one thing. And so that's what the M1 has really been about. It's about putting everything into one chip to reduce the power, make things faster, make things more efficient. And as you're going to see, it's really paying off. So this is the Wikipedia definition.
If I can just stick in a quick comment. I know we've got some people in the audience who are well, I'll call them anti-Apple bigots because they consider it a closed system, even though it's BSD at its core. And I think you're going to talk about in a few minutes or a little later the fact that all this new hardware, there are Linux developers who are.
Oh yeah, absolutely. I've got a whole section
on the M1. So.
Oh, absolutely. Yeah, don't worry, I've got that covered. So what's a system on it? And by the way, let me address that right now. You know, even if you hate Apple and you're like, I will never buy one of their devices, I think they're a terrible company, I don't like their practices. The fact is that what they're doing, everyone else is going to be doing in a few years, because that's always what happens. So I would argue it bears paying attention to these advances in hardware, because this is where the whole industry is going to be moving. You know, Intel, in fact, has announced that they would love to win back Apple's business by building fabrication plants where they will build these chips for Apple. In other words, Intel realizes Apple is not going to go back to Intel. There's absolutely no reason at this point to do it. They're kicking Intel's butt. But Intel would sure like to get some of that Apple business back. And the fact is that the Apple developments in terms of SoCs are going to be going throughout the industry. In fact, Google is now doing what Apple has been doing all along and making its own system on a chip. And so those of you that are Android users or like Chromebooks, you're going to be seeing the same type of thing now on Pixel 6s, but you're going to be seeing it throughout the entire industry. So if you're interested in technology in general and hardware, but you don't like Apple, I would still argue it's pretty important for you to pay attention to this if you want to know where things are going. So as Wikipedia defined it, I thought this might be helpful. A system on a chip is an integrated circuit that integrates all or most components of a computer. These components almost always include a CPU, the memory, input-output ports, secondary storage, alongside other components such as radio modems and the GPU, all on a single microchip. And so again, that's where we're going in terms of desktops as well as these. So, you know, when Apple announced the M1, they made some pretty big claims about it. They said it features the world's fastest CPU core in low power silicon, the world's best CPU performance per watt, the world's fastest integrated graphics in a personal computer. Now, I want you to parse that very carefully, because they're definitely couching it in reasonable terms. So they didn't say we're the fastest CPU. They said we're the fastest CPU core in low power silicon. They didn't say we have the best world CPU performance. They said we are aiming for the best CPU performance per watt. In other words, again, whoop. Is anybody there?
Yeah,
Hello?
I'm hearing you.
Okay, I just lost my own
Yeah, I
picture.
hear you, Scott.
Okay, I don't see myself or anybody else. That's weird. Okay, I'll just keep going. Oh, now I'm back. Weird. Okay. Let me start my video so you guys can see me. I can't start my video because the host is stopped. So somebody didn't like my face. Or that might be me. Am I hosting?
Sorry about that. I thought that was a stop it for only me.
Ah, yeah, I'm still stopped.
So I can ask you to start video.
There we go.
Woo.
There we go. Thank you. Technology is awesome. So again, they're couching this in terms of their goals. So definitely pay attention to that. Now, but they went on to say, the M1, we're seeing up to 3.5 times faster CPU performance, up to 6 times faster GPU performance, and up to 15 times faster machine learning. And this is the interesting thing, all while enabling battery life up to 2 times longer than previous generation Macs. Now that was a year ago when they announced this stuff. So let's look and see how they did. So this first, the M1 was the first PC chip among any that was built using a 5 nanometer process. And it had 16 billion transistors in it. You can see it right there on that screen. Now, when Apple announced it, I love how Apple makes these little charts that has everything on it. They pointed a couple of things out. Definitely the 5 nanometer process, which, by the way, Intel is still struggling with. They've been struggling with that for years. The 16 billion transistors, the neural engine, which is for machine learning, and so on. So this was our little chart about that. And then they broke it down even more in terms of exactly what they were doing in the chip. So as you can see there, cryptography acceleration, advanced display engine, performance controller. They really focused on high performance video editing as being something that they wanted to tune their chips for creatives and creative professionals and so on. So let's break down the chip. I thought you guys would find this pretty interesting. So the M1, the one that came out a year ago, has an 8-core CPU. And that provides, as they said, up to 3.5 times faster CPU performance. But if you look at the 8-core CPU, it's broken down into 2 groups of 4. There's 4 high performance cores, and those are obviously the ones when you really need the oomph and the power. And then there's 4 high efficiency cores, and those run at 1/10 of the power. And so that's one of the ways they really extend battery life to unheard of degrees, because most of the time it runs in high efficiency mode. It only goes to high performance when it's actually needed. And it does, they specifically have tuned this chip so it pays attention to that, does a really good job switching back and forth and keeping track of this. So the idea is that those high efficiency are for lightweight everyday tasks like email, web browsing, and those again are going to run at 1/10 the power. But they can work together with the 4 high performance cores when needed. So you can have a total of 8 cores if you really, really need it to be running. They provided an 8-core GPU, which again, they referred to as the world's fastest integrated graphics. And if you've ever used Intel's integrated graphics, you know that's not exactly a high bar there to me. And that, they specifically had tuned it, was designed to handle, could you say that again? And that's my watch. Designed to handle smooth playback of multiple 4K video streams and rendering 3D. Because again, one of the groups they're definitely targeting this at is creative professionals that do a lot of work in video and audio, and developers, by the way. I'm going to show you some examples of specifically what developers are saying about this stuff. And this is the other interesting thing. They've unified the memory architecture. So it's all joined together. And it actually, the CPU and the GPU can all use the same memory. So it's just available to everything on the chip. And people have discovered that this actually works out really well. And there have been many reports of people who bought the 8 gig Mac RAM, 8 gig of memory, MacBook Air or Mac Mini, and were amazed at how much they were able to do with only 8 gigs. You know, with my computer, I had it at 8 gigs several years ago, and it was just killing me because I was swapping all the time, and so I had to constantly keep an eye on what I had open and close things, and so I had to end up getting 32 gig of RAM. Well, people are reporting with just 8 gigs of integrated memory, it made a huge difference. So what are the benefits of unified memory architecture? Well, because everything in the SoC can access the memory, it can all access the same data without copying it between multiple pools of memory, thereby improving performance and efficiency, allowing things to run longer in terms of battery life, be more efficient, and so on. And so they included this chart at the time. And so they were basically saying, you know, the M1 goes higher in performance, but it uses less power consumption. And so versus the latest PC laptop chip, which may have a lot, you know, really good performance, not quite as high as the M1 at that wattage, at that power, but it also ends up using a lot more power and consequently much shorter battery life. And there's a dirty little secret about battery powered PC GPUs I'll be talking about in a second. And they also did that for GPUs as well. So the previous slide was CPU, this is GPU again. Better performance, lower power consumption. And Apple went on to say about this, this is the neural engine, the thing that's designed for machine learning, capable of 11 trillion operations per second. The neural engine enables up to 15 times faster machine learning. And if any of you guys follow what Apple's doing in AR, you know that that's one of the things they're looking at to really help them in terms of AR performance. In fact, the entire M1 chip is designed to excel at machine learning. Tasks like video analysis, voice recognition, and image processing will have a level of performance never seen before on a Mac. So
could you define the term AR, please?
I'm sorry, augmented reality. So virtual reality, you have a thing covering your entire face, right? And it's like you're in a 3D world. Augmented reality would be, I would take so if you've ever seen or heard of people playing Pokemon Go, where you would hold your phone out and you would see the real world on your phone wherever you were pointing it, but there'd be an overlay on top of it of Pokemons. And so it'd be integrating augmented reality, your world, with the stuff you see on your phone. And so IKEA has done that, for instance. The IKEA app available for iOS devices, you point it in your room at your wall and choose IKEA furniture, and it shows the furniture against your wall in your house, thus giving you a better opportunity to see what that stuff would look like in your actual home. James, your camera's on. Don't know if you know that. Maybe not. So does that
can
make
you hear
sense?
me?
Yeah.
Can you also hear me, Scott?
Yes.
So yeah, a classic example of augmented reality would be a heads-up display. Have you ever heard of a HUD? So that's where it overlays an electronic display over what you're seeing in the world. So the augmented reality might be conveyed through a camera on your phone with an overlay, or it might be through glasses on your face with an overlay of what you're seeing.
Right. Yep. One of the things Google Glass was trying to do, and we know Google is working on its own glasses. And we know, I mean, Apple hasn't confirmed this, but everybody knows it, that it's going to be AR using augmented reality for that. So the result was that Apple said the M1 was faster than 98% of PC laptops. 98% of PC laptops. So, you know, you can go read reviews. The reviewers were pretty unanimous that this was a major development in CPUs. But I thought it'd be fun just to show you this demonstration. It's a short video. This is on a MacBook Air. So this is a year old. And this person, you know, starts up their Mac. And by default, Apple has 18 apps sitting on the dock at the bottom. And this person's going to open all 18 as fast as they can. Now on a Mac, when you open an app, if it's opening, it'll bounce. And so a really slow to open app might bounce several times. I want you to notice, look at the bouncing that's occurring as this person is opening these 18 apps, one as fast as they possibly can. So here you go. And then Activity Monitor is equivalent to the Task Manager on Windows. So I would like you to know everything opened, most thing opened on a single bounce. I would like you to notice it opened up 18 apps. Notice this is on an 8, if you look at the bottom center of the Activity Monitor, this is on a machine with 8 gigs of RAM that used 5.6 to open all 18 of those apps, right? And it still has plenty left over out of the 8 gig. It's pretty amazing. It was really amazing. So that gives you an idea of the speed of the Apple M1, but that's a year ago. Let's look at what they announced in October. And again, the M1 was for the lower powered machines, the consumer machines. These are for professionals, video professionals, audio, creatives, developers, anybody that, you know, again, is a pro user of these types of machines. So just the size of the chips is going to tell you something right there in terms of what capabilities they're going to bring with them. So the M1, the M1 Pro, and the M1 Max. You can see the difference there. So that's the M1 Pro, and the memory there, you can see that, and this breaks it down for you. So the memory's on the sides there, and you can see here that this is a diagram from Apple kind of breaking down what you got here in terms of the performance cores and the GPU. Notice the GPU, instead of having 8 cores, now has 16 cores there. Notice before there were 8 cores of CPU, 4 high performance, 4 high efficiency, and this changes in the M1 Pro. Now there are 8 performance and 2 efficiency cores. And again, this is Apple's little chart showing you. So 33 billion transistors, for instance, 32 gig unified memory up to that, 10 core, 16 core GPU, 5 nanometers in terms of the process. And so that's the max. So this is the max with even more memory, and you can see that. And so now this one, again, 8 performance cores, 2 efficiency cores. But now this one has 32 cores for GPU. So the GPU performance now, they really focused on that quite a bit. And I'm going to show you what the result of that is in just a sec. Now we're up there. Yeah.
Neural engine, 11 trillion operations per second. What is the basic operation a neural engine makes?
Well, I'm far from a person that knows much about machine learning other than what its purpose is. But when you're talking about things like having to analyze, you know, augmented reality while calculating where things are and keeping track of the virtual layover of that, you can imagine that would be a very involved process.
Back in the old days, if you talked about a CPU doing 1 million operations per second, the kind of operations they were talking about back then might be adding 2 numbers stored in registers, right, or something like that.
Sure. Yeah,
I was wondering what these are when you talk about neural engine. What is the basic smallest computation that we're talking about doing 11 trillion of them in 1 second?
I don't have an answer to that because that's not my, as I said, that's not my area of knowledge. But anybody that does know, I'd love for anybody to feel free to jump in. As I said, the the example back here, right there, this focuses on neural engine for video analysis, voice recognition, image processing. And I'm sure there are plenty of others. If somebody wants to do a quick Wikipedia lookup for me and let me know, or let us all know, that'd be fantastic. So this is a video I wanted to show you guys. Now, this is about 5 to 6 minutes, but I want you guys to see this because this guy is the senior vice president of hardware technologies. This is the guy that's really been leading all these advances in the CPU in the last several years. He's from Israel, so he has a little bit of an accent. He spent time at other very well-known big companies, and this guy is just one of the top people in his field. And so I thought you would find it interesting kind of hearing from the horse's mouth while he explains what went into these CPUs to make them so special.
I am thrilled to introduce M1 Max. This incredible chip
this is about the
builds on
Max,
M1
not the Pro,
and takes its amazing capabilities to new heights. M1 Max starts with a much higher bandwidth on-chip fabric and doubles the memory interface once again. This delivers up to 400 gigabytes per second of memory bandwidth. That's twice M1 Pro and 6 times M1. This wider memory interface lets the M1 custom package support up to 64 gigabytes of unified memory. And its die has a staggering 57 billion transistors. That's 1.7 times M1 Pro and 3.5 times M1. It's the largest chip we've ever built by far. M1 Max has the same powerful 10-core CPU complex of M1 Pro and doubles the GPU to a massive 32 cores, giving M1 Max up to 4 times faster GPU performance than M1. And it has an even more capable media engine with up to 2 times faster video encoding and 2 porous accelerators. M1 Max delivers all of this with industry-leading performance per watt. For Apple Silicon, power efficiency defines system performance. That's why M1 is a breakthrough. When you look at its multi-core CPU performance versus power curve, it continues to crush the latest 4-core PC laptop chip. M1 is phenomenal. And when you add an M1 Pro and M1 Max, they deliver dramatically more performance. To put that in perspective, here is the latest 8-core PC laptop chip. M1 Pro and M1 Max have higher performance at every power level. At their peak, they deliver 1.7 times the performance of the PC chip in the same power envelope. And at the peak performance of the PC chip, they deliver the same performance at 70% less power. That's a big deal. Now here's the GPU performance versus power curve of M1. And here's the integrated graphics in that 8-core PC laptop chip. M1 easily outperforms it while using significantly less power. So when we add an M1 Pro, it's in a whole different class. At its peak, it's more than 7 times faster. Now, many PC laptops add a discrete GPU for better graphics performance. So here is a PC laptop with a powerful discrete GPU. M1 Pro delivers more performance while using 70% less power. But that's not all. There are compact Pro laptops that have higher performing, yet very power-hungry discrete GPUs. They deliver strong performance, but they consume a ton of power. And on a notebook, when you consume that much power, it means more heat, noisy fans, and less battery life. So let's look at M1 Max. It delivers comparable performance while using 40% less power. Now let's compare M1 Max to the chip running in the fastest PC laptop we could find. It's a high-end system that is much bigger and heavier than a compact Pro laptop. It delivers even faster graphics performance, but it also consumes a massive amount of power. Here, M1 Max delivers similar performance while using 100 watts less power. This is unheard of, and this remarkable efficiency means M1 Max performance is outstanding, plugged in or using the battery. If you look at the compact Pro laptop on battery, its graphics performance drops significantly. M1 Max is up to 2.5 times faster. And if you look at the high-end laptop when it's on battery, the drop-off in graphics performance is even more extreme. M1 Max is over 3 times faster. This is one of the huge advantages that Apple Silicon brings to our pro users. So that's M1 Max. Scaling up the M1 architecture even further. It's by far the most capable chip we've ever built. Simply put, it's the world's most powerful chip for a pro notebook.
Okay, so that's Johnny Cerulli explaining the M1 Max. And again, that's the dirty little secret I was talking about earlier. You can get these super high-end PC laptops with really great discrete GPUs. The problem is the second you go on battery power, the GPU goes down like that because it can't run full blast on battery power, or you would get 20 minutes of battery life out of the thing. So I thought he brought that out really well. In answer to the question about the neural engine, so neural engine is used for, say, Face ID, animated emoji, facial recognition, augmented reality, as we talked about that, speech processing, other user input processing, Siri. And remember, Apple doesn't like sending that stuff into the cloud to be analyzed. They want it to happen on device for privacy reasons. So that's why they focused on that. And Deep Fusion, which is a new feature in photography. And that basically analyzes photographs in real time. And when you take the photo, it does a better job of bringing out certain colors and darks and lights and things like that. And night mode, which I've actually used many times. It's amazing. But I'll take a photo outside in almost complete darkness and it looks like it's day. And obviously that's using the machine learning technology to figure all that out. There's another feature now on these the high-end MacBook Pros, where in the same way I'm using Zoom right now with the background blurred out, you can do that now with FaceTime and other technologies as well. And it does a little better job. You'll notice with Zoom, it's kind of getting confused when I do stuff like that. And from what I've read, the other one does a better job at it. Processing images and speech while learning to be better at doing so. Faster and more accurate augmented reality applications, image processing, speech recognition, and efficient use of hardware. So I hope that helps in terms of the answer.
Scott?
Yes.
I don't know if everybody can see my chat when I type to chat into the Zoom meeting. Can everybody see that?
I can.
Okay. So I'm pretty sure the neural engine goes hand in hand with the machine learning.
Oh yes, totally.
Right. And so a similar, if you wanted to dig into it and see what kind of stuff those kinds of chips are doing, Google had one. What was it called, Scott? TPU or something like that. I think that's Google's equivalent to Apple's neural engine chunk is their TPU. What was it called? Tensor?
Tensor is what I'm going to be talking about in just a little bit.
Right. So the stuff that the TPU is doing and the stuff that the Apple's neural engine chunk is doing is all this machine learning stuff that has all to do with the examples that you gave of analyzing and doing things with images and sound and things that we take for granted through our senses and computationally analyzing them and doing things with them.
Right. Which very well might mean why we have trillions of calculations going on, because stuff like that would take it. Our brain does it and we don't even realize it. Did everybody see his chat? If you want to follow up on that link, be my guest. So that's Johnny Cerulli talking. Let's keep going. So what did the reviewers say? So what a reviewer said about the M1 Pro and the M1 Max, because again, what you're getting a taste of now with this is what you're going to hopefully eventually see filter down through the rest of the industry. Well, the New York Times said the M1 chips make laptops as powerful as some of the fastest desktops on the market, yet so efficient. Their battery life beats that of just about every other laptop. And by the way, what people were really freaking out about with the M1 was the fact they were getting 14 hours of battery life easily, and so on. The result is something like the difference between a muscle car and a Tesla. The muscle car achieves high speeds with a huge engine that burns a lot of gasoline. The Tesla can hit even higher speeds while consuming less power because its electric motor is inherently more efficient than a gas engine. For years, Intel was making muscle cars. Apple's big innovation was to build the Tesla of computer chips. From The Verge, I'll just cut to the chase. For content creation and creative work, these are the most powerful laptops we've ever seen. And in fact, if you know anything about The Verge, you know they've never given a 10 out on any product. They gave these laptops 9.5. Now, by the way, she definitely makes very clear, as have other reviewers, that these laptops are not meant for gaming. They'll do some games, but you're not going to be getting best of class gaming performance out of these. It's not what Apple's really been interested in. So if you are a big gamer, you're going to want to buy a PC. This is Marquez Brownlee.
Is the gaming problem because of the nature of the hardware, or is it because the vendors only write games for Microsoft?
It is a little of the chicken and the egg, both. So Apple uses something called Metal, which is how it does it's like DirectX or Vulkan, an equivalent to that. And that's something a lot of game manufacturers are like, well, why should I have to rewrite everything to support this other, graphics drivers, basically. That's one thing. Macs haven't traditionally been used for AAA games. I mean, in terms of gaming, the iPhone is one of the top gaming platforms in the world, but we're talking casual gaming. We're not talking the latest AAA game that you go spend $75 on, and spend 2 weeks going through and, playing every day. So, we'll see where things go. But the GPUs in these machines you can play some games, but you're not going to get the kind of performance that you're going to get that you would on a PC tuned for gaming. And on top of that, again, gaming on the Mac, there's just not a lot of games that are made for the Mac. There's some, but many, top tier games are simply made for PC and consoles only, not for the Mac. Marquez Brownlee is one of the probably most widely known and widely respected reviewers on YouTube. And he basically does videos. I mean, that's his business. He makes video reviews of all sorts of technical products. And he said, when I tell you these laptops are next level, I mean that because the real world performance and the real world capabilities of these laptops is dramatically better than they have any business doing. I haven't been able to say something's truly next level in a really long time, but these are. It's one of my favorite products of the year, to be honest. And by the way, this is a guy that uses Windows, he uses Android, he uses iPhones. He does everything. He's not, an Apple person. This is from AnandTech. Now, if you guys know anything about AnandTech, they are pretty neutral. They really get as technical as possible and dig in. So they are not a bunch of, let's look at the shiny stuff. If you try to read one of their articles, they are extremely technical and really dig into the details. So I wanted to focus on what they said, because if AnandTech's saying this is something you should pay attention to. We expected large performance jumps, but we didn't expect some of the monstrous increases that the new chips are able to achieve. The M1 Pro and Max achieve performance figures that simply weren't even considered possible in a laptop chip. The chips here aren't only able to outclass any competitor laptop design, but also competes against the best desktop systems out there. You'd have to bring out server class hardware to get ahead of the M1 Max. It's just generally absurd. What's clear is that the new GPU does allow immense leaps in performance for content creation and performance workloads, which rely on GPU acceleration. The combination of raw performance, unique acceleration, as well as sheer power efficiency is something you just cannot find in any other platform right now, likely making the new MacBook Pros not just the best laptops, but outright the very best devices for the task. Now, again, that's AnandTech. And by the way, what about the battery life in these new ones? Well, Monica Chin from The Verge said the 16-inch MacBook Pro with the M1 Pro is the longest lasting laptop I've ever tested in my career as a hardware reviewer, like period. I get 16 hours of continuous use with the 16-inch M1 Pro model. I was jumping between a dozen-ish Chrome tabs, and Chrome is a hog, using a couple of apps like Slack and Spotify, which are made with, I'm blanking, Jans, what are they made with? Electron, which is a hog, and often running Zoom calls and YouTube videos over that. And I've never seen a laptop last that long. Guys, I defy you to try to do all that on your laptops. I mean, even on my laptop, I couldn't do this and get 16 hours of battery life out of that. That is, again, it's unheard of. It's amazing. And by the way, remember, it's running that, it's not reducing the power of the GPU while it's doing that. So let's look at developers. What have developers said about these new Macs? Okay, this is a little video from a Java developer and iOS developer. And I thought you'd find this kind of interesting.
Okay, so this is just absolutely insane. As you can see here, I'm running an iPhone 13 simulator, just buttery smooth through through map application. I've got YouTube pulled up on an Android Pixel 4 emulator, and I've got Chrome running on another Pixel 5 emulator. And you can see here, this is just absolutely insane, because normally when you would do something like this, it would catch one of these devices on fire. Like this i9 that I have sitting right here. With one emulator running, this would kick into full fan mode. Let's see here, at 47 gigs of utilized memory, and that's just from my day-to-day workflow. I love that this machine is actually giving me everything that I need to actually develop. So this is just a glimpse of a server project that I've been working on in my free time. It runs on the JVM, it's written in Kotlin, Spring Boot is the server. But anyways, there's a lot going on with this project. There's database component, image processing, a lot of different endpoints, APIs that we talk to for search and stuff like that. So what used to take many minutes, at least 5 minutes to run unit tests on this machine here. Let me just show you. I'm gonna do a clean build. And then I'm gonna run my tests. It just absolutely blows my mind how fast this is going. 20 seconds. Execution in 20 seconds. 5 minutes to 20 seconds. Like, the only difference I have made from this machine to this machine, which is, this is the i9, this is the M1 Max, is on this one is running a different JVM because it's for Apple Silicon. It's the Adopt JDK for ARM64, and over here it's, you know, the Intel-based 64-bit version. So it just so blows me away, like how much faster things are. Like, I don't know if you can see, but I've got many IDEs open. I've got three simulators running in the background here behind all of this. It's just amazing to me that it's able to just keep trucking along, and like it's still performing amazingly.
There you go. So I thought you'd find that interesting from a developer. Those are rookie numbers. I don't understand what that means, Tyler.
Tyler's one of those people who has 500 tabs open in their browser.
I run a Python celery queue whose master, or the key store that all the celery daemons watch for jobs. It's called the Kraken for a reason.
Mm-hmm.
I have to remind myself that I'm going to kill something if I actually throw everything at it like I normally do.
Interesting.
Let alone the sheer number of tabs I have open on stuff. 16 tabs? That's what will come up when I boot my system up.
Yeah, no, I get that. I often have 100 tabs open as well. Yeah. So this is from Twitter. So I want to show you what these different companies are doing for their developers now. So a staff software engineer at Twitter, I'm excited to be rolling out fully loaded M1 Max MacBook Pros to all of Twitter's iOS and Android engineers. We're seeing improvements in both top line performance and thermal throttling that currently plague our Intel builds. At Reddit, now he's comparing this to the 2019 i9 32 gig MacBook Pros. We recently found that the new 2021 M1 MacBook cut our Android build times in half. So for a team of 9, $32,000 of laptops will actually save $100,000 in productivity over the following year. The break-even point happens at 3 months. Engineering hours are much more expensive than laptops. I forgot to type this here. Sorry, this is from Uber. All active iOS engineers at Uber are getting upgraded to 16-inch M1 MacBook Pros with 64 gig of RAM, which includes new hires. And Shopify, this is a development manager at Shopify. Step 1, someone mentions how it'd be lovely to have M1 Max as our new work laptops in our developers Slack channel. 7 minutes later, there's an email in our inbox. Not only are we getting M1s, but we can keep our existing Macs because why not do the simple thing? Suddenly I want to work at Shopify. And the CEO of Shopify said, this was a really fun thing to announce. We put in a huge order for Apple Silicon. So a lot of these companies are moving to the new MacBook Pro with M1 Max, some to Pro, as fast as they can, because faster build times means more productivity for engineers, which means also happier engineers, because engineers will get to work with something that's faster and makes them feel more productive. So far, this is what Apple has in terms of the family. All 3 MacBook Pros, the 24-inch iMac, and the Mac Mini are all using M1 or M1 Pro or M1 Max at this point. Apple still, as I said, has to release the M1 Mac Pro and the iMac Pro. Now, what the rumors are is that supposedly are going to be based on the M1 Max, but with 2 dies instead of 1, because now we're talking desktops. So we'll see when that happens. Now, here's the deal. You can have all that power, you can have all that speed, it's gonna cost you. So you get options when you go to buy on Apple's website, the new MacBook Pros. You can either choose the M1 Pro with 10-core CPU, 16-core GPU, or the M1 Max with the 10-core CPU and either a 24 or 32-core GPU. You can choose either 16, 32, or 64 gig of unified memory, and you can choose either 1, 2, 4, or 8 terabytes of SSD storage. And by the way, I didn't put that in here, but the SSDs that Apple is now using, people are blown away by how fast those are as well. So what's it going to cost you? The low-end MacBook Pro is $2,000. If you want to get the larger storage, that's 512. If you want to get 1 terabyte on there and the faster GPU, that's going to be $24.99. Now hold on to your hats. I haven't even gotten to the Max. So this shows the prices, the Max. All of them have a 10-core CPU, but you're going from 16 to 32 GPU. You're going from 16 to 32 gig of memory. You're going from 512 to 1 terabyte of storage, and you go from $24.99 all the way up to $34.99. And there's additional, because remember, you can add 2, 4, or 8 terabytes of storage, and you can go up to 64 gigs of unified memory, and you're going to be talking well north of that. So, yep, these things cost a lot of money. But if you're a developer,
those are the Max, but on the top line of each of the columns, the first 2 columns say it's a Pro.
Oh, God dang it. You're right. Damn it, Gary. I screwed up. I need to fix that. I'll fix that.
Okay, these are all actually Max in each of the columns.
These are all this. No, I'm sorry. I'm wrong. I am right here. These are the 16-inch screens. These were the 14-inch screens, and those come with the Pro, but you can upgrade it to the Max in the 14-inch screens. So on any of these laptops, you can use the M1 Pro or the M1 Max. You can upgrade an M1 Pro to an M1 Max. You can upgrade the memory, 16, 32, or 64 gig. You can upgrade the storage, 1, 2, 4, or 8. These are all 14-inch. So the starting price for the 14-inch with the Mac Pro is $19.99. The starting price for the 14-inch with the Mac Pro with 1 terabyte of storage is $24.99. Then we get to here. These are all 16-inch. So the 16-inch with the Mac Pro is going to run you $24.99 all the way up to a starting price for the 16-inch with 32-core GPU, 10-core CPU, 1 terabyte of storage. That's going to run you $34.99. And by the way, the other thing I didn't mention here, because I didn't have time, is everybody is also raving about the quality of the screen, that it's the best screen people have ever seen in a laptop and so on. So yeah, they're expensive. But again, you can see why these large companies are buying these for their developers. You can see why other developers are interested in buying it. You can see why people that edit video for a living or edit audio or make music want to pursue these, because they'll make their lives much easier. They'll get things done faster, better, and so on. So let's talk about Intel for a second. Yeah.
I just double checked. Yeah, your slide is correct. It was your words that were wrong.
Yep. Thank you. Yeah, I got this straight off Apple's website earlier today. So let's talk about Intel's latest chip. The 12th generation Core, which is codenamed Alder Lake. So this just rolled out a few days ago. So this is the latest i9. The top of the line Intel chip is a 10 nanometer. Notice again, Apple's already at 7 and 5, and Intel is stuck at 10. But this is the i9. It has 16 cores, 8 performance cores, 8 performance, 8 efficiency cores that do not have symmetric multi-threading. Let's contrast that. AMD's best consumer CPU, the 7 nanometer 5950X, has 16 cores, also all high performance. So Intel's going 8 and 8, AMD's just all 16 high performance chips. Well, it's interesting because now, for the first time in years and years and years, Intel actually is beating AMD's best consumer CPU for single and multi-threaded. Now we're talking desktop. That i9 is a desktop chip. There are no Alder Lake mobile CPUs yet. Those are coming next year. So this is only for desktop performance. So Intel is finally beating AMD. As I said, they're expecting to release laptop class chips of these in early 22. We'll see. According to Geekbench 5 benchmarks, Alder Lake is 1.5 times faster than the M1 Pro and the M1 Max when it comes to multi-core performance. So you can see there that the Core i9 gets 18,500 in the Geekbench scores, and M1 Pro, M1 Max is 12,500. Well, gosh, the i9, that must be a lot better than the MacBook Pros. Remember, this is a desktop chip versus a laptop chip. So you would expect better performance in a desktop chip than you would a laptop chip. But there's a bigger problem, and that is power consumption. According to Intel, this is Intel, Alder Lake uses 125 watts at just base power and up to 241 watts at maximum turbo power. Ars Technica, in their review of the Alder Lake chip, found that this chip drew more than 300 watts of system power, over 100 watts higher than the AMD. So basically, this thing requires a ton of power, and it runs really hot. The reviews were all like, man, this thing is roasting hot. So as John Gruber pointed out, Intel seems only capable of performing at the extremes, very fast performance CPU at all costs that consume amazing amounts of power, or power efficient chips that run really slowly. The sweet spot is in the middle, and that's what Intel's trying for. And that's why I said we will see what happens when they release their mobile chip. Because that mobile chip, I'm willing to bet it's going to be very powerful with terrible battery life and amazing amounts of heat. So we will see, but that is my prediction based on the entire history of Intel. Remember, Apple never said Apple Silicon would be the fastest. They said performance per watt. So let's talk about Linux. So you can imagine when the super fast M1 got announced, as Linux people do, several people were like, I need to run Linux on that. So people have started looking into that. We've actually had a couple of solutions. The first one, I think this is one we're all going to want to keep an eye on, is called Asahi Linux. This is a brand new distro started in January of 2020. And as it says here, Asahi Linux has the goal of porting Linux to Apple Silicon Macs, starting with the 2020 M1, Mac Mini, MacBook Air, and MacBook Pro. Our goal is not just to make it run, but to polish it to the point where it can be used as a daily OS. And obviously this is going to take a lot of work. They're having to reverse engineer everything. And here's their GitHub page. Again, the URLs are all in the notes that I'll be sending along with these, with the PDF. So you can go and check out their GitHub page and see what they're doing. They're making pretty good progress according to them. So this is from their FAQ. And I thought some of you guys would definitely want to know this. Is this a Linux distribution? Asahi Linux is an overall project to develop support for these Macs. We will eventually release a remix of Arch Linux ARM packaged for installation by end users as a distribution of the same name. So this is going to be a variant of Arch for ARM that's you're going to be able to download and install on your M1 devices. And by the way, yes, they're very aware of the M1 Max and Pro. They've already gotten a copy of those or bought those laptops themselves, and they are busy looking over those to see what's going to happen. Now, this is the lead of the GPU coding for Asahi Linux. So this is a Linux user using the M1, and she said, everything just happens instantly. What? Computers haven't felt this fast since before I was born. So again, this is a Linux user trying to port Linux over to run on these machines, and she's blown away by this. And remember, these are the M1s, not the M1 Pro or Max. This is the M1, and she's saying everything just happens instantly. In fact, the progress report for Asahi Linux, which came out October 6th, just a month ago, said, with these drivers that they've been developing, M1 Macs are actually usable as desktop Linux machines. While there is no GPU acceleration yet, this is nuts, this next sentence, the M1 CPUs are so powerful that a software rendered desktop is actually faster on them than on, for example, Rockchip ARM64 machines with hardware acceleration. That's nuts. Remember, there are still many missing bits, USB 3, Thunderbolt, camera, GPU audio, as well as patch sets, a bit too problematic to bundle as is at the time, for instance, Wi-Fi. So don't expect this to be anywhere near the polished experience that is the goal of the project, but you can actually use it. And again, there's still no GPU acceleration, and it's still a software rendered desktop is faster on them than on other ARM64 machines with hardware acceleration. Now, the other thing is Corellium, which is a company that makes virtualized iOS devices. Apple didn't like that and sued them and lost, thank goodness. I thought Apple was in the wrong there and Corellium was in the right because security researchers need this.
Question.
Yeah.
That developer that we saw running an iPhone simulator earlier, was he running Corellium?
I have no idea. No idea. Go to his YouTube channel. You'll have the URL. I'll give it to you at the end. You know, it's in the notes, and ask. He'll answer. You know, I have no idea. So sorry. But this guy, this is the CTO of Corellium, and obviously they have an interest in this. And they said using what they've developed, this is not Asahi, this is a separate thing. Linux is now completely usable on the M1 Mini. Booting via, now you have to boot from USB, and if you do, you get a full Linux Ubuntu desktop. Network has to use a USB-C dongle though, you can't use that. You can't use Wi-Fi. Updates include supports for USB, I2C, Dart. We will push changes to our GitHub and a tutorial later today. So if you want, you can actually do this and use Corellium, again, an Ubuntu desktop running on it. Or, and I know some of you guys will be like, what? This is really cool news. Turns out the Linux kernel now supports Apple M1s. As of June of this year, Linux kernel 5.13 was released with initial support, native kernel support for the Apple M1 SoC. Now, it's still a work in progress. And again, there's still no mainline support for the GPU, but Apple computer owners with an M1 can now run Linux natively if you want. So that's a pretty big deal. So we've got three different fronts here for Linux on the M1. We've got the kernel itself, which obviously is going to provide the best performance. We've got the Asahi people working away on their distro, and I imagine they're thrilled about the built-in support here for the Apple M1. And we've got Corellium doing its thing. So there are options available, and there will be more options to come, but this is pretty exciting news. So what about what's next after the M1? What about the M2? And I'm making that up. We don't know. I have the feeling it'll probably be called M2, but we'll see. Well, the first generation was the M1. The second generation was the M1 Pro and the M1 Max. We still don't know what they're going to call the one that's going to be in the the iMac Pro and the Mac Pro. So I'm calling that M ? For this point. It's expected to be made with a 3 nanometer process. So we are talking way ahead of Intel at this point, way. And we're also they're expecting that they're going to use 2 dies instead of 1. So we'll have even more processor cores available to handle those really big professional desktop machines. Now we do know this.
Describe what having 2 dies would mean. I mean, obviously
Well,
they're built, but
that would mean double the processor cores, more GPU cores, more of everything by having 2 dies. So the M1 Max you saw was big, so the M1's this big, the M1 Pro's this big, the M1 Max is gigantic. Well, imagine 2 of that size. What would be possible with that? So that's probably where people are thinking they're going to go with this, to really ramp up the power for the top line professional desktop machines. So that 3rd gen, well, we do know the code names. We know Lobos and Palma, because they're already working on the successors for the M1 and the M1 Pro and the M1 Max. Obviously, Lobos and Palma are the code names for the MacBook Pro and Mac desktops, and Ibiza are for the iPads and the MacBook Airs. Those will be the lower performance. That's all we know right now. We don't know anything else. As you all know, Apple is famously secretive, and we don't know for sure. So what about Google? Well, Google realized that it needed to get in the game as well. Virtually all Android flagship phones have used Qualcomm's Snapdragon. Today, they're all using Snapdragon 888. Well, and the previous Pixels have done that as well. Remember, the Pixel is Google's flagship. This is how Android ought to be done. I've always said, if I had to buy an Android, I would buy a Pixel because it's as close to what the maker of Android intends. You don't get all that third-party crap layered on top from the other makers and so on. They also have some of the best support policies, although they got dinged on that recently in terms of being kind of chintzy on how long they support it. But the point is that Google up to now has relied on the same chip as everybody else, the same SoC, the Qualcomm Snapdragon. Well, that changed when they announced their very first system on a chip in a smartphone. So again, they're doing what Apple's doing. They're making their own designs for their own ARM chips for use in their phones. And they called it the Google Tensor. And so TPU, as Jan's mentioned earlier, that's the machine learning engine that Apple calls its machine learning engine, the neural engine, an advanced image signal processor. Now, this is not to scale, obviously. They just kind of divided this up. But notice you'll get 8 cores for the CPU, 2 high performance, 2 mid, 4 high efficiency, and a 20-core GPU. And so what they have, this is the breakdown, all 5 nanometers, 2 2.8 gigahertz X1 cores for peak single-threaded performance, 2 2.5 gigahertz cores for medium foreground work, and then 4 1.8 gigahertz cores for low-power background work. So that's how they decided to split up the 8 cores they're using for the CPU. And it turns out it's done very well in many ways. Now you can see that's compared to the Galaxy running the Snapdragon. So it's not that it's dramatically better at this point, but they held their own. It's matching the single core performance of the Galaxy S1 in most ways. And that's a good thing. They weren't trying to come out of the gate and get way ahead of the Snapdragon. They were trying to come out of the gate with something that's decent and works. And that shows multi-core performance. And you see the Galaxy still does better in certain things. But again, the point is they're making their own now, and it's going to iterate and get better and better. In fact, I love this from Google, peak GPU and CPU speeds look great in benchmarks, but don't always reflect real-world user performance. In other words, well, benchmarks are one thing, but how is it performing in the real world? And remember that the couple of the things about it is the Tensor GPU is not custom. So that's the thing. They are not making their own GPUs yet, just the system on a chip. They're designing that. They're designing the CPU, but not the GPUs. They've integrated them, but they're not designing them. They're using off the shelf ARM Mail G78 MP20s, which are comparable to what you see from Qualcomm in the Samsung Galaxy. And the other thing that they got dinged for at Ars Technica is that the modem is a separate chip. So that's not ideal. So
Scott,
why would you?
This is Stan.
Yeah.
Where are they making these things? In Taiwan or Philadelphia or
Taiwan.
what?
Taiwan.
Thank you.
In Gary's basement. So there's 2 reasons why you would have a separate modem. Number one is you've got a new immature technology. You're going to roll it out for testing purposes to a single generation. So for example, when 5G got rolled out in 2019 by Qualcomm, they had a separate 5G modem with the Snapdragon 855 while they were kind of working the kinks out and getting it to work and so on, or IP reasons, so-called intellectual property reasons. So for instance, Apple has separate modems in the A15 for iPhones for 5G. They are not allowed to integrate it because Qualcomm won't allow them to do it. But as a result, Apple is very busy developing its own modems that it will integrate into its chips. Let me tell you, we know that for a fact. So right now there's a separate modem. We'll see what Google does about that, but we know Apple is, they're sick of Qualcomm. They want to get out from under having to pay Qualcomm. In fact, they took them to court about their licensing fees and lost. So they're trying as fast as they can to come up with their own modem to be added into the SoC. So this is what Ars Technica said about the Tensor. The Tensor is not dramatically different from Qualcomm's best SoC in day-to-day usage, which is a compliment. It's fine. Google didn't screw it up. So they're saying, look, it's fine. It works about as well as the current SoCs, and it's going to get better. So that's a good thing.
Question.
And so, yeah.
The Tensor is in all of the Pixel phones for 4, 5, and 6?
Nope, Pixel 6 only.
Oh, the Pixel 4 and 5 do not have Tensor.
Nope. Oh, no. No. In fact, people were, in many ways, reviews I read at the time were very disappointed and certainly in the Pixel 5. Wasn't much of an upgrade. But the Pixel 6 has the new Tensor chip. It's got a camera bar. So all you guys that made fun of the iPhone camera bump, well, you can eat it because now that bar is completely raised all across the entire back of the Pixel 6 Pro, and it's big. So if you want to get Google Tensor, its new system on a chip, then you go get the Pixel 6 Pro. And then I finally want to talk about the framework. This is really an interesting idea. We will see what happens with it, but I know some of you guys I thought would be very interested in this. So this is a laptop. Now, I mean, it's a laptop. What's the big deal about a laptop? This is a modular laptop. So in other words, you know, if you're upset at Apple because you can't repair laptops anymore, you can't replace the RAM, and you can't change the drive, and you know, you can't tinker in with the hardware, and you don't like the direction other laptop manufacturers are going by locking up their systems, then man, the framework is made for you, because this laptop is one specifically designed for tinkerers and people that want a totally modular system. So the big deal is it has a marketplace for the hardware. And if you read across the top there, you can buy the laptop, you can buy expansion cards, which I'm going to show you in just a sec, which plug into the side, kind of like the old PCM CIA cards, except now that's the only way to do ports on the side. These laptops have two empty places on each side that you slide expansion cards into. And that is the only way to get extra capabilities on the laptop. You can customize the main board, you can customize the memory and the storage, you can customize the keyboards, you can customize various parts, and even the tools. So let me show you what I mean by that. So these are those expansion cards. There are 6 available, that's it. One is storage. You can either get 250 gig or 1 terabyte. And by the way, you could buy 2 of these and plug these both on one side if you wanted. DisplayPort, HDMI, SD card, USB-A, USB-C. Now remember, you got 4 ports, that's it. So you got to mix and match these as you see fit for your device. All of them have USB-C on the end. That's how they plug in. So the reviewers I read said you kind of push it in, it snugly locks into place, and now you've got your add-on ability. So hey, I don't need DisplayPort, now I need HDMI. Great, pull it out, put the other one in, you're now good to go. I want more storage. Well, great, get a 1 terabyte instead of a 250 gig, and so on. You need USB-A, plug the USB-A in. Now you need USB-C, plug the USB-C in.
Question.
Yeah.
The storage module, that's for extra storage. There's still an SSD inside the thing, right?
I believe so.
Yes.
Thank you.
I'm actually watching you on one right now.
And what operating
Put it
system does
together.
this laptop run?
I'm getting to that. I'm getting to that. Hold on about the OS. You can even customize the color of the bezels, which I thought was kind of cool, black, gray, or orange. These are some of the parts. So an audio board, a fingerprint reader, heatsink and fan, power adapter, an Intel Wi-Fi chip, a hinge kit. So, I mean, virtually any of the major parts of this laptop, you can purchase on this marketplace for your own repair, your own changing, whatever you want. It's going to be available to you. Main boards, you've got your choice of 1 i5 or 2 i7 main boards if you want to change it out. And you get 2 choices for laptop. You can buy the framework laptop that starts at $999, or, and I know some of you are going to be going, oh, that's for me, the DIY do-it-yourself edition that starts at $750. So in terms of the pre-made laptops, here are your 3 choices that you can then configure from there. But for $999, you get the i5 with 8 gig of memory, 256 gig storage, Wi-Fi 6, and Windows. For $1399, you get an i7, 16 gig memory, 512 gig storage, and Windows 10 Home. For $1999, you get the i7 with 32 gig of RAM, 1 terabyte storage, and Windows 10 Pro. And notice by that point, you're up to the cost of an M1 Max. Sorry, an M1 Pro. You're up to an M1 Pro. So it kind of depends on what, your priorities are.
What size screen are these?
I think I have,
Pixels or physical?
they're all 14-inch.
14-inch, thank you.
Yep. Now, that was the pre-made laptop. What about the DIY? Well, I found this short little video, silent, where they're showing you sped up how you might work on your DIY framework laptop. Comes with that screwdriver, by the way, which is I believe a T5. This is definitely not a system on a chip. Boom.
This company knows what right to repair means.
Oh yeah, and they emphasize that on their website.
Are those external modules hot swappable?
I have no idea.
Yes.
They
I
are.
thought they would be. I
Nice.
assumed they would be. So there you
It's
go.
just a USB. I mean, the question is if a dongle is built into the system's chassis, is it still a dongle?
Well, they're not calling them dongles. And so what about Linux? Hey, guess what? We decided from the start of Framework to offer a DIY edition without an operating system preloaded to give you the option to bring your favorite Linux distro. In fact, it is outselling pre-configured systems with Windows 10 by a large margin. And in fact, and you notice there, they said we gave this hardware to engineers at Fedora, Elementary, Nix, and Arch, so they could make sure it worked well on our hardware. And they've been impressed by the variety of distros and OpenBSD, of course, because OpenBSD runs on everything. So there you go. I thought some of you guys would definitely find that pretty darn interesting, but there are problems with it. But this is a first generation product. So, I always say, saying cut it some slack. Yeah, it's got problems, but it's a first gen product. What do you expect to have happen? So some of the problems: the power button has a built-in fingerprint scanner, which is convenient, though I had trouble getting it to recognize my finger on the first try every time. Regardless of the memory size, the Framework laptop trails behind the Samsung and Razer notebooks in benchmark, and those are comparable. The Framework's battery life is also too short. It lasted 5 hours and a few minutes before it petered out. And this is the most worrying thing. I wonder if its numbers would have ranked better if it didn't run so hot. Throughout the benchmarking process, I clocked the Framework laptop running about 108 degrees Fahrenheit. At some points, the computer felt too hot to touch. The laptop does work at cooling itself, which I can tell because it's loud enough to become a noisy distraction. I've only ever experienced this kind of fan activity with high-performance gaming laptops. But even at the lowest setting, the thermometer was clocking in 96-degree temperatures around the function keys. And finally, the Framework laptop has a standard Intel integrated graphics chip, so don't expect to do much gaming beyond the occasional virtual card game. But again, this is a first-gen product. This is an experiment. So, if you want to spend money on it, God, more power to you, do it. But don't expect a completely polished, perfectly working, smooth machine, because that ain't what this is. This is aimed at a different kind of audience. People that like you, like me, want to tinker with stuff and play around with stuff and experiment and try new, interesting hardware. So I'm just pointing that out. I'm not coming down on this thing at all. I think it's really cool and very impressive, but just be aware of what you're getting. So to sum up.
This is Stan. One of the things that they even said on their own website, they are relying on the fact that people will come back for upgrades. So
of course.
So they're hoping that the market will accept them and do good things for them.
So from what I've been told is when they release the next generation of the laptop, you should be able to order the main board and swap it out with your existing case.
Yep. That's definitely their goal. They've said they've tried to make everything, work forward as much as possible. So, which is good. All right. So to sum up, talked about 5 things tonight: the M1, the M1 Pro, and the M1 Max, and where they are and where they're going, and why developers, creators, and others are so excited about them. The Intel 12th Gen Core, where it is in terms of desktops, and we'll see what it does with mobile. I don't think it's going to be much of a competitor, frankly, to the M1s when it comes to laptops. We'll see. The Google Tensor, which is certainly augmenting a really cool new direction for Google to go in. I think it's about time that they took control of their own hardware completely and really started trying to make the Pixel what it should have been all along. And finally, the Framework laptop, this modular laptop that gives tinkerers, DIYers, people that simply want to be able to repair as much as they want their devices, that option. So those are the 5 things that I've talked about tonight. I'm curious what any questions or what you guys found interesting. So
I find
I counted
interesting that
6 things, not 5.
What was the 6th thing?
Oh, you said M1, M1 Max, M1 Pro, Intel.
I grouped the Pro and the Max together because they came out the same.
Okay.
But yeah.
I find it interesting that Apple isn't comparing it's comparing itself to Intel, not to AMD. Their processor design is kind of the exact opposite of AMD's chiplet design, where
Interesting.
you screw up one thing.
Tyler, I would have to look. Apple actually labeled the computers they were testing against in their comparisons. They're in the charts in the bottom right. I don't know if any of those were MD or not. But they might not have been.
They seem hyper focused on Intel, which is kind of like beating on the last person in the pack, especially right now that finally Intel has got something competitive against the Ryzen processor line after what, 5 years of having their rear end handed to them,
or longer. Yeah. Yep.
I did notice you missed the next generation of EPYC processors is going to go the same direction that the M1 is they're going to combine high performance cores along with efficiency performance in the AMD EPYC, or the next generation of EPYC. So we can see that weird thing. Also, funny thing about this mix of power and efficiency cores in the 12th generation Alder Lake, it is wreaking havoc on anti-cheat software.
What do you mean?
Software will boot up or games will boot up and try to run, and the anti-cheat will scream to the top of its lungs something's going wrong because it got shoved on an efficiency core instead of a power core, and it thinks something screwy is going on. So that's interesting little interaction between the power and the efficiency core interactions. Cool. Still, I find it disingenuous of Apple comparing its laptop efficiency to traditionally or to desktop CPUs. It's just it's apples and oranges.
They did not compare their M1 Pro.
They were weren't they comparing it to the 12th gen? You said that there's no mobile 12th gen.
No, I was showing that because some people have been saying, oh, the Intel Alder Lake's going to kill the M1. It's much, much better than the M1. Apple didn't do that. No, I'm sorry if you got that. No, I never.
I sit here on a laptop for work with a 12 NVIDIA Quadro N 1200 in my laptop. I don't personally use it, but all the performance laptops are geared the same because rewrite the software Apple uses to design that chassis. And we actually write that CAD CAM. And I'm just looking at this system on the chip as a disaster in the making, because we've seen it where we'll load up things like the model for a car and we'll eat 12 gig of memory just computing all the vectors on that model for CAD CAM. So, but I guess that's just my personal opinion on computer builds. Having things like memory soldered on anything but the lowest end devices is just asking for trouble.
Well, no reviewers have found that in over a year. So.
Well, no reviewers have been loaded up something as demanding as a car.
Well, you might talk to people that are editing 8K video in ProRes. I don't know. I don't follow CAD, so I have no idea. Is there CAD software at this point really made for the Mac?
Well, that's the big thing that
beyond the
Mac
basic.
That's the biggest problem with the M1, with the M1 chipset, is that will your application port over? I know from our point of view, the Apple has complained back and forth that we've never ported NX over to run on an Apple OS.
Okay.
They literally have a machine in the data center that runs the software, and they port the screen out to them so that they can use NX. It's the same thing like with Photoshop. I think that Adobe is still working on porting that onto Photoshop. If it's there,
I'm not sure where Adobe is. I know some things that have now been ported over to M1 or not. The thing I forgot to mention to everybody is that Apple has a technology called Rosetta 2 that allows you to run x86 compiled apps on an M1. And from what I've read, in many, if not most cases, it runs extremely fast, faster than it did on the Intel. So, okay, how about somebody else? Somebody else's turn. How about you, Ed? What'd you find interesting?
Well, I've got a Mac already, and so I'm just looking at the possibility that if this particular Mac, I mean, I depend on it because of the accessibility part, and
Yeah.
I imagine that the neural stuff is only going to make that better. I mean, that's what my
one would hope.
Yeah, one would hope on that. But then, since this is my primary window into the world, I guess you would call it. If this goes south on me, my backup plan is to get. I was just thinking about just getting the straight up low end M1 Mini or the Mac Mini M1, and because I don't really need to have the high best greatest screen in the world. So
sure.
It should be good. So anyway, that's and it's a really good price. I mean, I was kind of surprised by the price. I mean, the Mac M1 started at $699, I think. So
good.
And I've got this great keyboard that I just got, which is wireless, so I work perfectly with that.
Cool. Good. How about you, Grant? I'm picking on everybody in here one at a time. Got a microphone, Grant?
Hi, Scott. Yeah, you just done a fantastic job. I really appreciate it. Thanks so much.
Thank you. What did you find most interesting?
Well, everything. I'm a newbie to this level of computers. So I just found all of it just fascinating and don't know half of what I'm hearing. So understand half of what I'm hearing, but I'm still in.
Well, if you watch the video 5 or 6 times, you should begin to get it.
I think it will help me out. I came in a little bit late, you may have noticed.
Sure. No problem. No problem at all.
Okay.
How about you? Thanks, Grant. I appreciate it.
Yeah.
How about you, Tom? Tom Kirk?
Yeah. I was actually just looking up expansion port. I've got a Mac M1 Mac Mini, and they make an expansion port that you put the Mac Mini on with, and then you can put an external, a SSD drive in it and use it as a second device to start up. And I was thinking about trying to get one of those Linux versions to try out on it.
Yeah, be cool.
In fact, I was trying to look for that. I remembered a review on it, but I couldn't find the one that I'd seen before. But anyhow, that's
right.
But I had actually bought it for my wife, but I'm going to have to see if I can steal it back from her. But we'll see what happens.
Oh, and by the way, I forgot to mention also, you can of course run Linux and Windows using Linux, certainly using virtual machines.
Right.
Tom, you said you have an M1 Mini. What are your thoughts on that?
It runs. I've also had a 212 Mac Mini, the server variety, and I put I transferred the operating system over to. And I ended up putting a second SSD drive, a SSD drive in the server version, and it almost kept up with the new M1, to be truthful, because of the increased drives, the SSD drive. But the M1 was very, very fast. And I got it because my wife kept getting bogged down trying to download emails and was giving me crap about it.
Okay. Well, that's always a good reason to fix things because the wife's giving you crap.
Yeah.
What was that base station you were talking about for the Mac Mini?
I'm not sure. Yeah, the base station. I was going to try to get that and then put an SSD drive in it and put a. I don't like trying to use virtual machines, particularly if I'd have to depend on the operating systems.
Terry wants to know the name of the product.
Oh, I haven't found the one I was looking for yet. There's a couple of them out there and I haven't found it yet. But that's what I was, I read a review for it. I think it was actually in,
I thought you said you already bought one.
No, I didn't buy the expansion port. I did buy an M1 Mac Mini. Okay.
Okay.
But I wanted I don't want to fool with the SSD drive on the Mac Mini. I want to try have a separate SSD drive so that if I mess something up, which isn't unusual for me, I don't mess up the operating system and have to start over again.
Cool. Tom, thanks. Let me move on to somebody else. As always, thank you. Carrie, how about you?
I was blown away by the quality of the speech. It's just missing. Again, I'm another newbie kind of thing. This is far beyond my past experience. Love the presentation.
Well, thank you. We were all like that though at one time, just keep learning.
I'm too old. I may be too old to do that much learning.
No, I doubt that. Yeah, but that's great. Keep at it. Thank you. Steve, how about you? Steve Stegman. Keep thinking you guys have to run in the other room to get the mic.
He might be asleep.
Oh, well, Lee, how about you then?
I can't believe you people waste so much money on this stuff.
I knew you were going to say that. I knew you were going to say that.
Just for that amount of price, you could buy about 35 Raspberry Pi 4s with 8 gigs of RAM.
Yeah. True. Although, you know, like I said, for certain people, it's exactly what they need. But I get that attitude, sure.
Raspberry Pis aren't a laptop.
That's true.
I beg to differ.
You can make them one.
You can get yourself a Raspberry Pi 4, or sorry, what is it? That the 400, right? The 400, which is an all-in-one system. All you need to do is add a screen, and you have essentially a laptop.
You do have a laptop, and if I take some boards and put some tricycle wheels on it, I've got, you know, a 4-wheel car. But that doesn't mean it's what you want to use all the time.
I have a Raspberry Pi laptop.
Oh, I'm sure. I'm sure you do.
There's some cases out there that will turn it into a full-blown laptop.
Sure. How about you, Joe? What did you find most interesting?
Oh, I liked the whole thing. It was a great presentation. I'd been kind of watching the new M1s for a while, and I was debating whether to go with the Mini or go ahead and get one. I got my first iMac a couple of years ago. It was a used one that I didn't pay that much for, and I wanted to use it for music recording and stuff. But it was like a 2015 circa model, and I couldn't upgrade the OS, run GarageBand, and do the music stuff I wanted to do with it. So a year ago, I went out and invested in an iPad, which works great for that.
Oh yeah.
And I'm wondering with the multi-die chip, whatever, if those are going to be stacked or how they're going to do that. You know, that'd be interesting to see what they're going to, how much bigger it would get, or if it's just going to get thicker, what they're going to do, and what that would, having 2 dies, how it would affect the performance of it. But yeah, I was waiting to see how the reviews went as far as new chip, new technology. You don't know if the bugs are all shaken out till you get a bunch of people using it and say, oh, well, it's great, but it has a heat problem or whatever else, you know.
Right.
It's great, but it's got a higher failure rate, you know. So I've been keeping an eye on them and thinking about the Mini. My take is, as far as the screen, I normally always use the laptop with an external monitor. So I wouldn't consider spending extra money for the larger 16-inch screen, even though it's crisp and everything, because I normally don't have the lid open on any of the laptops I'm using.
Sure. And I go back and forth between an external monitor, my laptop, or just the laptop. So for me, I would like the screen, but I totally get that.
There was one problem with the Mac, the M1 Mac Mini. I ended up trying to use Apple monitors initially, and I messed one up totally. You can't use the older style Apple monitors with the new Mac Mini with the M1 chip. It'll fry them.
Was it a port problem or what?
No, I had to use a different monitor totally.
Interesting.
But it damaged the laptop or
No,
the Mini or the monitor?
It damaged the monitor.
Okay.
But how old were those monitors? Apple hasn't made monitors since.
Yeah, the monitors were old.
Yeah.
But
it's been a while.
Yep. They were older monitors. They're the ones with the external power supplies. And
that's pretty old.
But I think one of them was a 27-inch. That's the big one I messed up. But anyhow, just a caution to people that you need to be very careful with the monitor you use on the Mac Mini.
How do you know which monitors are appropriate? You think you got an HDMI cable in your hand, and the person's going to think you can connect it to any HDMI screen. So how do you know what's right for the M1 Mac Mini?
I think it needs to be designed. This monitor needs to be designed for an HDMI input. Okay.
Oh, you mean you just need to make sure that the monitor, you're not using an adapter on the monitor, and the monitor already has an HDMI port? Is that what you're saying?
Yes.
How about DisplayPort? Does the Mac Mini have a DisplayPort on the back, like Thunderbolt DisplayPort?
I
bet it does.
I used an adapter to go from a DisplayPort adapter to go to HDMI.
Yeah.
So the computer was HDMI, and then you took an HDMI cable to a display port adapter, and that went into the monitor, and you fried the monitor.
Mm-hmm.
So remember, the Macs have USB-C ports, and those are Thunderbolt ports. And I believe you could plug your monitor in with that or HDMI.
Yeah, I did try to use the HDMI, the C port with a another adapter, and it had the same problem. This is when I was trying to use what I had when I first got it. So just a caution, that's all.
Okay, good. Stan, how about you?
I really like the breadth of what you covered here. I every week try to listen to Mac Break Weekly to see what the other side of the river's like. And I've been trying to follow along with this M1 and the Apple stuff and everything. And the timelines and the graphics you used gave me a better idea of what's going on there. And the Intel, where they are in the river, they're dog paddling, I guess. But your take on where they are now, and it has been very informative to me. And I had just barely heard about the Google Tensor thing in the last day or so. The framework thing, I've been watching them since I discovered them about 3 months ago, and it's all I can do to keep them ordering one.
Right.
But I don't need to order one. I got 2 laptops sitting here and 3 in the other room.
Oh yeah, I know that feeling.
And I think the only reason I keep talking myself out of buying one of those is they don't have Ethernet. It's all Wi-Fi. So.
Oh. They don't sell. That's right. One of the adapters was an Ethernet, was it?
Right.
But you could get a USB-C or a dongle.
Yes, but they also said on their website that they're pretty much trying to make everything open documentation. So they wouldn't be against somebody else manufacturing other dongles or whatever they call those things.
On the framework, there's already somebody. On the framework laptop, they've already voted in to have somebody build a Ethernet module.
Oh, good.
Full-blown gig Ethernet. So.
Well, good. It'll be much more difficult for me talking myself out of ordering one of these things.
There you go. Yeah, I know the feeling because I lease my Mac, and I get a new one every 2 years, and so I got to wait till May. So
my sister-in-law, my sister-in-law fried her PC last week, and I offered to buy one of these frameworks to send down to her so that she could try it out for me.
Nice.
Oh, by the way, when you install Linux on a framework, make sure the Linux kernel's updated to 5.10 at least. Everything works so much better after that kernel update.
Good to know.
Good to know.
All right, cool. Anonymous Coward, you got anything, Dad?
That's me. That's why
right.
I record the session with.
That's right. That's right. Well, I guess the last one's Gary. How about you, Gary? Did I forget anybody else?
Gary needs to buy a new machine.
Gary needs to get a better
Boy,
phone.
I get that credit card out and let me just go for it now. Let's see. Yeah, a great presentation. Obviously, you touched on all kinds of good things, which has me just salivating here. Let's see. In reference to Tom Kirk's comment about burning out the old monitors, I'm thinking that probably, with the cable, the individual interfaces, the voltages were probably right, but I'm just guessing here, that probably the scan rate,
That's what I was thinking too. Yeah.
So just scanning too fast for it. Let's see. You touched on it at a couple of points, and I was wondering about the emulation mode, and so you did answer my question. I'd love to see actual numbers though of both for the Microsoft operating system and also for Linux running in emulation mode on the M1s. And
I've heard they're very, very, very fast because the Parallels, which is the one I use, which is probably the most widely used, and VMware, those work on the M1. So they're running in the emulator itself, the virtual machine is running it at native speed. So, you know, it should be pretty good. The holdup now, of course, is Microsoft needs to make a version of ARM for Windows or Windows for ARM that is actually publicly sold instead of just being an insider's edition. So, you know, once they do that, then we could see more about wider use and maybe even bringing back boot camp to the M1 where you can easily dual boot into Windows. Because what I've done on my Mac is I like to play games on it, and I'm okay. I just buy older games and I boot into Windows to play games, and then I boot back into Mac OS to do most of my work 98% of the time. But I won't be able to do that when I get an M1 Mac because it doesn't natively support Windows. So
has anybody heard about whether Oracle is porting VirtualBox over to the M1?
I have no idea. In fact, I think I read they're not.
Oh, that's a pain.
But we know why. Because Oracle are dicks. That's
Well,
why.
that's true.
What about Zen?
I thought Oracle is where software goes to die.
And Yahoo is where internet services go to die.
Wow.
I'm looking that up. VirtualBox only supports 32-bit Windows, and there's no support for ARM. It looks like it's got real problems running on it with VirtualBox. So I don't know.
Doing the comparison between the Google Tensor and the Apple Silicon, would there be, you think Google may actually be thinking of bringing out a laptop or a desktop machine based on the Tensor?
Oh, Chromebooks, right?
Chromebooks, yeah.
Why? They got their USB-C dongle device that does the tensor compute.
Yeah. So I don't think they're obviously not going to make a Windows laptop. You know. What about Zen? Or is that not? I don't think Zen is ARM. Right?
AMD just announced something kind of interesting around the accelerator market. So you know how they made the chiplet design on their CPUs?
Mm-mm.
They did it again with the GPU. They're currently releasing a 2-chiplet RNDA2 accelerator for data centers.
Interesting.
So it looks like they are going to try to pull the same trick again with GPU acceleration.
I don't see anything about Zen and M1s. To the person that asked about that.
I got a thing about not Zen, but Apple has made known that they intend in the next generation of the ARM processors, their Apple Silicon, that they're going to support ARM v9, which just came out. And ARM v9 is intended, amongst many, many other things, to have better support for hypervisors. It's sort of built in, like kind of what they're doing right now with most ARM chips is that it's a software type of thing. But Intel chips typically have support built in for hypervisor support, at the low level, at the kind of at the
Yeah.
core part of the processor. ARM hasn't typically had that. So the ARM v9 will have that, and that's probably going to improve a lot of support for these various products as Zen and maybe even VirtualBox. I don't know.
Cool. Good to know. Anybody else?
Kind of as a related point, this afternoon I posted and discussed the URL for some article in foronics.com. It was talking about in Linux kernel 5.13, they're in the process of rewriting the PCIe bus driver so it's native for the M1. And there's also some other articles. It seems like about every 2-3 weeks, maybe a month, there's another Foronics article about where they're at with writing native Linux for the M1.
They're a good source. When I give you guys these slides, I'm going to give you a PDF and a text file. The text file has all the links and citations, and that's keyed to the slides in the PDF.
Cool. Send those to editor if you would, Scott.
Sure.
And again, I'd like to thank you personally. Every time you present, you give us 150% of what I expect. It's been
Thank
great.
You. I appreciate it. It was fun. I had to learn
Yeah.
stuff.
I have an idea on your earlier question about the number of, what were those things called? The operations per second in the neural engine.
The neural engine. Yeah.
Yeah. And what was that? It was something like 1 point something trillion.
17 trillion.
Oh, 17 trillion. Oh my
Yeah.
God. Okay. So the neural engine, I'm assuming, I don't know how they've structured theirs. I'm assuming it's what they call a deep neural net, which means it has gobs and gobs of layers where one layer feeds the next layer, which feeds the next layer, and so on and so forth, right? So the way that neural networks work in terms of training, right, is that you present a whole lot of signals on the input, and you're looking for some expected output on the output, and there's this feedback loop in there, right? And the feedback loop is saying, okay, yeah, that's matching what we think it is or whatever. Oh, that doesn't quite match what we think it is, so we're going to reject that and stuff like that. Now, all of those little individual nodes in there, right, are all little adder multipliers, right? So there's a little addition thing happening, a little multiplication thing happening. And each one of those things, right, you can think of those as individual CPUs, although, they're very limited CPUs. They're not like CPUs, your traditional CPUs that can just run loops or whatever, right? They just take an input and they perform a discrete operation, and then they generate an output, and then that just gets fed through the entire network. All right, so the question is, what exactly are they claiming as an operation per second? In other words, are they saying they've got, I don't think they have trillions of these things. I think they have a lot of them running in parallel, and they're saying, well, if we had some standard metric for, let's say, the typical metric is like how many CPPSs there are. That's like cat pictures per second, right? Like that's how many, like how many of those operations would it take a normal thing to work at? It's a bit like the old MIPS battle, right? Like how many millions of instructions per second, right? They would say, okay, well, how many of these can we do per second, right? And that's so damn fast that I don't think that there's 17 trillion, little nodes inside there, right, that are all operating parallel. I think it's just that they're going so damn fast that they're standard metric. That's just a guess, but I don't know.
Yeah. I mean, when I look up on this, it says 1600, the first neural engine was introduced with the A11 in 2017, could perform up to 600 billion operations per second for real-time processing of machine learning algorithms dedicated to features such as Animoji and Face ID. Blah, 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 blah. And now the M1.
Right. It
to-
sounds like they have a metric, right? They have like, you know, given some standard algorithm, right? Whatever that is, right? You know, how many inputs can it process? And then how fast can it be trained, right? That somehow gets translated into operations per second.
Right.
And it's just kind of a, I think it's a fuzzy picture, but that's just me.
Yeah, I'm sure somewhere they've defined it, but I don't know. Like I
Yeah.
said, it's not my area of, far from my area of expertise. So
Now, I would be very impressed if they, well, you know, you only mentioned that they, well, they didn't say how many transistors they had in the neural engine, or was that total on the entire SoC? How many billions was it?
that was the CPU.
Only the CPU
Wait,
itself?
was it? Was it? I'd have to look.
Yeah,
have to look.
yeah, because I mean, obviously, you'd have more, you know, nodes inside of that neural engine, and how many of transistors does that take up, right? You know, is that part of that count or not? I don't know.
Okay, guys, the library closed 20 minutes ago, just
Oh,
by
yeah.
tradition. Well, this has been too much fun. It really is. It really is.
Great evening.
Yeah, I do have one very, very important announcement that I was supposed to have made at the Gushy Middle, and that is next Thursday, a week from tomorrow, is our traditional Linux user group, St. Louis Linux user group meeting. And I screwed up last month. We had planned to celebrate the 25th anniversary of the Internet Archive. And we had some speaker who was set up to do that. What was his name? Oh yeah, it was Scott. And due to a misplaced pronoun, I screwed up, and we got him scheduled to speak next week instead. So
Yes.
even though it's now 25 years plus 1 month, Scott's going to tell us everything we ever wanted to know about the Internet Archive next Thursday.
In fact, I donated money to him today.
Woo, woo. All right.
I use them so much.
So come back next week on Thursday, and you'll get to hear Scott again.
Oh yeah, look forward to it. It's good. I love the Internet Archive, and there's so much to it. There's so many cool aspects to it. So I can't wait to watch you guys do that.
Nice.
So I guarantee there's stuff you didn't know was on there that's on there.
I get my son to find stuff for me on there because I have terrible Google foo and archive foo. I just can't find anything, but I'll talk to him or I'll talk to Phil Bunch and they find that stuff for me. It's just amazing out there.
Yeah. Good. Very good.
Yeah, I had some problems trying to find the ancient archives of really old versions of Ruby and versions of Ruby on Rails, and from the Internet Archive. So I was able to find them, but I had to use some auxiliary sources in some cases. So they're as good as what people submit, and that can be a problem sometimes.
Cool.
Let's see. It sounds like we're kind of winding down on Scott's topic for this evening. Any other final questions or comments before we officially close the specific questions for this talk?
I have a question.
Yes, sir.
So when I installed Linux Mint, initially installed 5.04, what's the easy way to get Mint to install the beta or the newer versions of the kernel?
I really couldn't tell you that, because I've stopped at 20.0, the long-term support thing. I just wanted to be stable with that. And I mean, in the previous 19 series, it seemed like it going from 19 to 19.1 to 19.2, it allowed you to go to the higher kernels. It's all in the archives, I guess. And what I really don't have enough full knowledge of how they set that up to really say.
Because in the end, I had to pull deb files off of the kernel.org page and install them, and then it promptly said, "You want to upgrade to?" Because I pulled the 5.10 kernel packages, installed them, and then it turned around and said, "Do you want to install 5.13?" I said, "Might as well."
Yeah. A lot of surprising stuff there when you start doing that. I mean, I've done it in the past, but I just didn't want to.
Right.
In the last 2 years, I didn't want to go down that rabbit hole because it's too much fun. It really is. And I back myself into corners that why am I here? What am I doing?
Because I figured I probably should put a post up on the framework sites for other people to say, hey, when you get your laptop and you're installing Linux, make sure you force it to update the kernel to 5.10 at least, so that devices will work.
Right. So, you're still using the Linux Mint with your gaming and so forth, or have you?
Yeah, I'm still on my main rig. I figured I'd try out the other distros on this laptop, not only testing it, but
from what I have read in the past, Pop! OS is the best Linux for supporting gamers.
Tell that to Linus.
Yeah,
I'm using that on 3 machines right now.
You like it?
Yes.
On the Discuss, I sent a link to his guide. He and one of his colleagues over at the Linus Media Group went on a 1-month challenge of playing games on Linux.
Really?
He went on Pop! OS. He said app install Steam. They threw out some major errors and says, you have to type, yes, I know what I'm doing, do this. Then it nuked the desktop environment.
Ouch. Yeah. I missed that posting.
Well, it knew
I just threw it out there, but it's interesting that somebody in Pop
install a
needs to.
Steam add-on and it didn't have any problems with it.
No.
I'm sorry, Tom, say that again. It got a little
I
dark.
did install the Steam add-on for Pop! OS and I didn't have any problems with it.
Okay. Thank you.
I honestly wonder, so many of these things seem to me to be, it's got to be some hardware anomaly somewhere that just accounts for people having different problems. That's all I can think of.
They do specify that you need to use at least a 2 gig video card.
So,
yeah.
On the other hand, his colleague used Mint and had no issues.
Interesting.
So score 1 for Linux Mint.
Cool.
Interesting.
Oh, I threw the link to the video into the Discuss channel if you want to watch it on YouTube.
Oh, thank you.
And laugh at the noobs trying to run Linux.
This is so much fun. Oh my.
All right.
Any other questions relating to tonight's talk?
Yeah, otherwise I'm going to sign off.
Thank you again.
Thank you very much, Scott.
All
Appreciate
right,
it.
I'll see y'all in a week and a day.